Good morning, good morning, good morning, good morning. All right. So let me show you what we're doing today. One of the problems with streaming is I can't listen to music. You're like, oh, but you could like pipe it. So yeah, that's too hard for me, guys. That's why the streams are shorter. That's why the streams are less. But regardless, I have a stream for you guys today. Let me show you. Okay. So you'll see if I do dgem equals 1, Python 3 extra kernel search. You'll see no test equals 1 to do that. Okay, but you see that my matrix multiply, we're multiplying a 2048 by 2048 square matrix, and I'm getting a pathetic 3.7 teraflops. But if we go into the PyTorch version, the PyTorch version is actually even faster than this. Where's my, here, I do M1 PyTorch, right? So we'll just run that, extra gem M1 PyTorch. We're getting 7.1 gigaflops, and it's actually faster because like this is kind of slow. The problem is without this, it's not synchronizing. Let's see if we can find a cheaper way to make it synchronize. How do I do that? What do I get? No, see, this is fake. Am I looking for interns for the tinycorp? Yeah, you can intern with the tinycorp, but first submit pull requests. Like, if you can't submit pull requests, why the fuck would I want to use an intern, right? Good morning, good morning, good morning, everybody. Good morning. Okay, so like, I don't know. Do I have to do detach or something? No, that's just slower. I found this to be the fastest way to make it actually like synchronize the metal kernels. But actually that's giving me crappy numbers now. Okay, whatever. Because we don't have like a metal synchronized thing. So I found this. The question is, somehow Apple has a gem kernel that's getting good numbers, and my gem kernel is getting bad numbers. We're drinking, it's not beer, it's a highball, guys. We're drinking highballs. It's not alcohol. It's an energy drink. It's got all my B vitamins in it. It's got guarana, ginseng, caffeine. It's got no calories. You can't drink like Monster and shit because it's got calories. So this is an open source GPU, the beginning of the open source GPU driver, and it actually does build. I don't know why that doesn't build, but if I do make wrap dylib and then I insert it, it actually does work. The problem is when I insert it, I really like this way of doing things. Like you can just, you can tell like this is like the smart way to like approach this. So we're just gonna fix up this code. I'll show you what happens and why we can't just use it. Dylib, insert libraries. I spell libraries right. Wrap.dylib. Okay. Wait, what? Oh, I think this already has my fixes in it. Yeah, but those fixes are wrong, unfortunately. Don't talk shit about me. You know it makes me mad and it comes back to bite you. Hello, Chili. It's Friday night in India. Yo, I'm thinking of going to India this year. I'm thinking of going to India, and I'm thinking of, I did the Iceland bike trip last year. I think of doing an India bike trip. So let me know if in the comments if you guys think that that's crazy. Am I gonna die? That's mostly what I'm interested in. Not a good idea. Why do you say that? Are you in India? You're from India and that's crazy. Well, crazy's okay. Bring nose plugs, just don't eat street food. All right. Yo, actually, honestly, I've been a little off. I went to Mexico last week, and yeah, it's been rough. It's been rough. Okay. So, you know what? This is complicated. Let me write a minimal program and then hit that. Because this is using PyTorch is complicated. CL minimal. There's the one where I just do the empty kernel. That should work, right? Now we can do the minimal kernel. Let's do the minimal kernel. Minimal. Okay. How many calls to submit command buffers do I have? A lot. Okay, well, let's modify this to not dump so much because I don't really care. Cycling from Singapore to Thailand. Oh, that's cool. I did that on. I did that by train. Actually walked across the Malaysia border. I've never been to Africa. I don't know. I mean, I'm excited. India's growing, which is exciting. I guess there's growth in Africa too. There's probably some wild stuff there. Okay, these are the input structs and the output structs. Command Q ID. All right, you guys are off topic, so you're gonna get subscriber only. Congratulations. See, like, look at this. I just don't trust this. Like, it's not calling create command queue with that. I just don't believe it. Just comment out these hex dumps. Return struct that's being dumped and taking up tons of space. All right, so what this thing is a where do I see you? This is a call to allocate mem. This is a program that's intercepting the calls, the Apple IOKit calls to the GPU. So let's get an understanding. Okay. Oh, let's also, we can separate the run of the thing from the So here, setup done. Okay. So for this run, it's somehow allocating, wow, it's allocating a ton of memory. These GPU drivers are crazy, bro. I'll just run it a few times. Oh, but that didn't finish. Should actually flush the whole buffer there. Whatever. Don't talk shit about me. You know it makes me mad when it comes. Actually, it's probably less. If I do that, it probably like create something. What is it? So from runtime import cl, it's like cl.clq dot. Is that gonna work? No. What's it called? That finish. Okay, cool. So we just have to focus on this one call to submit command buffers. All right. I don't really care about the freeze. Just need to focus on this call to submit command buffers. When I say gem kernel, it's an actual layout and hardware. No, it's a metal kernel. So we just need to focus on, you see how I isolated this thing? So we're just gonna need to submit command buffers, and like, ideally I'd like to like get out the number 1237, right? Cool. Because then that will tell us a lot. This is the global size of the kernel. Should we give the kernel a local size too? Give the kernel a local size. Okay, cool. So we're going to try to figure out how to extract these numbers from the thing, and then we can know how the gem kernel is at least running, right? So do you want me to explain noob opencl shit to you? Opencl global local, right? If you don't get it, like, look at this picture, okay? Right? So there's your global IDs, there's your local IDs, and it like goes around it like a, yeah, you know what I'm saying. Right? If you don't get it, then, you know, Google something, browse. All right, good. So we're just trying to figure out those numbers, okay? So here is submit command buffers, and of course it's the one that's broken. So let's print out input struct count and input count. Because those asserts didn't work when I tried to do it. Why did they light up? Okay. Stupid C++. Okay, well, it has an unsigned long, but it has type uint t. Okay, what do I do for uint t? Oh man, is that right? Okay. Okay, so input struct count is 56 and input count is 4. Great. So that's a lot of stuff. That's changed a lot. So it's an IOConnect control buffer. Input struct is a input count. You know, can we just talk about what garbage documentation this is, Apple? Thank you. Thank you for this great documentation. It really tells me what this function does. Yeah, it really changed a lot. Okay, if input struct count, we dump the struct. But what if input count is more than 1? Input sub 0. Okay. Wait, I don't understand why that isn't falling through. That should print there, right? Where are those numbers? Oh, those are the numbers. I see. I see. And we commented that out. Okay. Okay. It's calling submit command buffers with the inputs are 2, 0, 1, and 38. All right. Well, that's kind of weird. Like, I should know this. This is a very common thing. Here, maybe Project Zero did a better job documenting it. IOConnectCallMethod. I'm not hooking anything with Python. I'm just using the Python. The Python is just so I can call opencl kernels. It's just PyOpenCL. All right, Apple. I wish you gave me more documentation. Okay. So our inputs. Oh, I see. So the inputs are literally numbers. And then we can have input structs. And the input struct count is actually a size. Let's dump the struct. All right, you guys can count how many times I forget to hit make. We have 2 pointers there and there. This struct clearly changed. That seems plausible. Unc. 2 user pointers. So we don't know what these are, but the command buffer is 0. Why did it say ID is, oh, ID is supposedly input sub 0, except this might have all changed. This clearly is reverse engineered. Okay, GPUs basically work like they have they build up these command buffers and they submit the command buffers and then we can dump them and take a look at them. Okay, HEX submit command buffer. No, that's a thing to actually use it. Okay. And buff equals, oh, and then these unc things are not, and it didn't set any of the user pointers, which kind of sucks. Okay. Well, we might have to go back to, is there a place where we allocate a command buffer? Here, create command buff. So we might have to track them when we create them. What do you think of that? Let's see, pan code, command stream. Just dump all the command buffers if we can. Pan code, find command buffer. This probably works actually. I don't know what dump mapping is, but all right, let's just try this. non-existent command buffer. Command buff not equal to null. Well, unfortunately, it's null because did this work before? What's pandy code? Oh, that is 56. I'm just, you're not thinking hexadecimally. All right, so what's 30? 40? That's 40 in hex. 28. All right, so there were two things added clearly. Yeah, that'd be 28. Okay, so there's more stuff, and it looks like it was added at the end. I don't actually know if that's command buff 0. That might just be wrong. But either way, where do we allocate the command buffers? Create command buff. Am I doing anything special for that? Oh, here we go, create command buff. Track AGX here. Pan code track alloc. Index map. I did create command buff. Man, you know, who else hates C++? Map, size, type. Index is word sub1. Map is star pointer, not the star. Words and np sub1. Why doesn't it like that star? Okay, now that's an unsigned long, so we're going to need to change that to LLU. Gotta love C++. Gotta love that you gotta type that. Okay. Here we go. So we're doing the create command buffs, and they're here. Does that land in the same place every time? No, it doesn't. Okay. Create command buff 3, 4. Oh look, those became 6s and 5s after I did that. That's just weird. Okay, sometimes it's 6, sometimes 5. Great. But those are probably actually the command buffs, which is interesting. It's probably lying to me. Okay, we create 3, 4, and then we do. Let's say those things are. Command buff and mappings. Interesting. So my guess is that it just moved there, and those are command buff and mappings, and now the unc0 and unc1 are the command buffers. You know, before I go crazy with this, is there a pull request to fix this? No, there's not. Oh, maybe. No, useless. And now it's, so the development of this has moved to the Mesa, and now they're just working on making a driver for Linux. So there's probably not an up-to-date version of this somewhere. Alright, let's just try like on 0. Maybe that works. Now it dumped this command buffer. Oh, look at that. Cool. So unc zeros may be wrong because that says all ones. I did put ones here. All right, let's just tag these 4, 5, 6. Don't talk shit about me. You know it makes me mad and it comes back to bite you. Segfault 11. Okay. That's probably wrong then. Maybe we actually want to hit. We just got lucky there. Unc1. Non-existent command buffer. That's sad. Didn't I create the command buffer? Okay, well that one doesn't exist. This one definitely is 0, okay? So don't tell me 0 doesn't exist. Command buff not equal to null. Oh, it's so exciting that we got that one to dump though. You know what the good news is? Once we actually find the command buffer, they can't really change that because that's in the hardware. Oh yeah. Okay. File decode.c. Okay, which is a type AGX-alloc command buff? 2. There's only one command buff. And it's definitely unc 0. So maybe we just got unlucky. There's only one thing allocated with type command buff, and it's at index 2. So that seems right. Okay. Let's take a look at pantycode dump. Okay, so for some reason this is 4. Which is still something we're launching. There isn't another launching here, is there? Oh, stupid. Look at that. There we go. Those are the numbers we're looking for, right there. If we look at that, and we take that number and we divide it by 4, we get 1237. Okay, cool. Great. All right, we're dumping the command buffer. Now let's target the gem. Extra gem M1 PyTorch. Okay. Did we dump something? All right, we dumped something. Ho-ho! Let's look at the launches. I mean, it's got to be that, right? Okay. Well, we're trying to figure out what the MPS is doing in the GPU to get fast gems. Exactly. Okay. So there's a few interesting things here to note. Look at the group size and local size. By the way, thank you. This code worked out great. It's got to be that launch. So now a few things to note. If we debug my launch here, I have both a global size and a local size. This thing doesn't waste any time with that. And if we do 512 times 512, we get that. So they're clearly doing 1024 times 1024. Okay. Good to know. Well, we can get 1024 by 1024. And then their local size is 1024, which is also different from my local size. Wait. That shouldn't even be allowed. Fucking cheaters. When I set a local size at 1024, it doesn't work. Oh. I knew something was off. So you'll see that the biggest local size I'm allowed is max workgroup size 256. Yet somehow they have a workgroup size of 1024. Fucking cheaters. Bro! You can't just do that. It's opencl versus metal, but still. Why do they only give me... I knew the local size of 256 was appallingly small. Okay, so if I change my thing to, for example... well, okay, actually, let's just test one thing. So this is odd because 2048 times 2048 is that. So each of the things is creating 4 numbers. Each of the things is storing 4 numbers. So like I can do a few things here. So I have some hacks on strides. Out, and we go in here to kernel search, and if I, like, for example, remove that, we should get no. Oh, that's just because that's fine. If we do an outcast with 1. This thing called access nums. Okay. So now my kernels are the same global size, and we should set access nums to this. And how many github do I get? Okay. 2,000. Because they're cheaters. You guys, like how disheartening is it when it turns out that Apple's just cheating because when I put in big numbers, it just fails. No, they did this on purpose to make opencl upsettingly bad. Like I just can't set that local size. I want to just like, fuck you, Apple. How much do you enjoy MacBooks and you're a subscriber? Why do you think that's a good question? They're just cheaters. Bro, I can cheat. They're just cheaters. Cheaters, cheaters, cheaters. Okay. Well, what are we going to do about that? It's not a language barrier. It's just a misunderstanding of what makes a good question. All right, let's try that. Yeah, same shit. Okay, so like it's clearly okay. First off, a few things to note. We're clearly hitting the right thing because when I hit 1024, okay, so each kernel is outputting 4 values. We know that, right? We know that for a fact. But they use this upsetting local size. We'll notice that that's a pathetic amount of gigaflops that they get with that one. But it's not really fair because, again, a lot of that comes down to timing. Okay. Try 496. Not really dumb. Yeah, okay, so same crap. So the global size is n times n divided by 4, 1, 1. And the local size is 1024. You know, this also explains how they're doing their reduced kernels. So I looked into like my reduced kernels are slow. And why are my reduced kernels slow? I'm in some broken branch of thing, but I drove myself crazy trying to figure out why my reduced kernels were slower than the metal reduced kernels. And now we know why. Fucking cheaters, man. You know. Okay, opencl on metal. Linking to opencl dylib. Bro, I don't even understand what any of this is. Like, they're just shitty people, and that's why they said I could only have 256 workgroup size. Yeah, bro, we all want to cheat. Everyone loves cheating. See, all right, so let's, okay. To be fair, we haven't totally ruled everything out yet. Let's just try, okay, external. All right, let's just, oh, look, I'm casually going to be Apple. Let's just try 1024 times 1024, 1024. No, let's match what I saw for the other one. Okay, so this is 2048 times 2048 divided by 4. And then just look, my local size is 1024. Look, this should totally work, right? Didn't we just see Apple do it? Oh, whoa. Invalid work item size, guys. It's an invalid work item size. We can't use that big number. We can't use 1024 like metal. Oh, metal gets 1024, but we have to use sad, pathetic 256. All right, let's pandy code dump these. Wait. Hang on. Whoa, guys. There might just be a bug. I just put in 256, and for some reason it gave me a local size of 1024. All right, all right, all right. Maybe no one's cheating here. Hang on, hang on, hang on. So what if I set my local size to 1? Still 1024. That's very suspicious. Wait, I don't get it. Oh, am I launching? I'm launching the gem. Oh, I'm launching the wrong thing. Hang on. Okay. I set local size to 32. It sets local size to 32 when I set local size to 1. Maybe it doesn't actually respect my local size. No respect. When we run the matmul, we definitely get that. Okay. Okay, so it doesn't actually respect my local size. You know what? Let's see if I can detect that it doesn't respect my local size. What is it? Global float pointer a sub 0 equals get local size 0. We actually have to create an a buffer. Copy it to numpy. Interesting. Okay. Wait a second. That one gave me 2. But yet if I type 1, oh, why did I get 32 before when I typed 1? Now I get 32. It just crashes sometimes. 256. No. Okay. So guys, I was not just jumping to conclusions. It's a jump to conclusions, Matt. I was not just jumping to conclusions. They actually are fucking cheaters, man. And you know, it's just incredibly disheartening that Apple would just cheat, and that's why they get better performance than me. Because if I type in 1024, like because I want speed, I get a crash that says invalid work item size. But when they do it, they don't get that crash. So I don't know what we're gonna do about this except cry. See the 256? Get, if I change this to, I don't know what these little kernels are. These little kernels are stupid. No, there's nothing quantum. Wait a second. Changes state when observed. Bro, you might be right. You might be right. Because I set this to 1. And I got 1. But if I don't observe it, 32! Ha ha! Caught you! Oh, quantum guy, you're smart, bro. Yo, did you see what they did? They tricked me, man. They tricked me. They tricked me. You gotta be kidding me. Wait. Let's not jump to conclusions. Okay, you see now it's 1 because I get the local size. But what if instead of getting the local size, I just assign that to 0? What do I get? A cycle. 32. It's only if you look at it. All right. So you know what this has told me? This has told me that this is fucking bullshit. And we need control. We need to get to the metal. So we're going to take these pills, and then we're going to figure out if we can run metal from Python. Fucking cheaters. The guy who wrote the opencl driver at Apple is like, they'll never unlock 1024 performance. They only deserve 256. They should use metal. We're gonna deprecate opencl. I can't wait till we deprecate opencl. We're gonna slowly make it shittier and shittier. We broke the performance counters, and we broke the 1024 local size, and we are going to make it shittier. Oh, by the way, can we just say for a second how when I do CL info on NVIDIA, you know, the max work item size is 1024. So, you know, it's very possible to make a work item size of 1024, but just Apple didn't do it because they suck. We're gonna deprecate opencl. All right, so it sounds like we need metal. Python metal. Oh yes, I'm just going to conveniently write some Swift and no, I hate this. Okay, I actually have some metal code here, and I used this, but I don't know if any of this works. Metal Q. No, he's not allowed. We told you we're going to deprecate opencl. In the next update, you will only give them 64. But what if they wrote code that relied on it being too big? 64. It's legal in the opencl spec. We checked. Okay. Just increase the metal API version and. I think this is a different metal. By the way, okay, so I looked into the API that Torch is actually using, and they're using this like graph API. Okay, these look normal. Pi metal bridge. Is there a way to like... Let's think for a minute. Does Apple support Vulkan? Oh, pip metal compute library. All right, let's see. A library able to run metal compute. Oh, nice. Good find. Oh, I think we got it. I think we got it. Okay. We're just going to have to write another wrapper. Metal minimal. I didn't want to have to use metal, by the way. But if we have to use metal, we have to use metal. All right. Let's just install this. No, let's look it over and see and make sure it's not too sketchy. Great. No, this metal compute library looks good. Status, this is a preview version. It has 21 stars, which is kind of upsetting. Andrew Baldwin. Do you think you're doing your part to make the world a better place? Someday I'll join Mastodon and vote no. If I really wanted to do my part to make the world a better place, I would participate in the global system of capital and try to maximize my money and my consumption. That's what a good accelerationist would do. Okay. Why is it called Pi Metal Compute? Metal Compute. Okay, it built. That's the first battle. Okay, import metal compute as MC, devices get devices. Don't you love abstractions? The simple narrative taught in every history classes. Look, it's almost CUDA. Except it uses brackets. Well, let's just see if metal allows what I want. I'm not going to spend all this time making metal work and then just be upset. Kernel call count? Wait, they get less TFLOPS than me. Never at the top, it just feels so unreachable. I dropped out of college because I'm completely unteachable. Any Python buffer object. Oh, metal shading language is a C++ 14 subset. That's not allowed in C++, is it? And if it is allowed in C++, I don't even know anymore. Number of kernel calls. Is that local or? I think this is right. I think that this is abstracting away what I need. Is this it? Oh yeah, it's just hard coded there. Max. No, see, no, but like this is a, yeah. Oh, okay, so this is like almost what we want, but like not really. Is it time to fork it? Yeah, maybe. Wait, is that's a real thing? Oh. Attributes. Use the deprecated attribute. Okay, they're attributes. Okay, well, it's good to know that metalcompute exists. So yeah, we're gonna have to fork it or something. Is there like something like metal info, which is like CL info? Because if I get to the bottom of this and I can't even like do this, we're gonna have to write Swift code. We're gonna have to download Xcode. I'm getting more upset by the minute, guys. We're getting more upset by the minute. If I have to download Xcode, that's it. That's it. That's it. This is just y'all can keep your M1s. Oh. Alright, so what should we do? Should we be upset about this, or should we push on and try to fix it? Alright, well, it's good to know that metalcompute exists. We can't use it, unfortunately, because for some reason they do this. I also don't really trust this project because it has 21 stars. But thank you for writing it, because you've made me believe that this is at least possible. The other meta libraries do not seem to do this. Over 9,000 TFLOPS. Yeah, I don't know about that. That'd be 9 petaflops. That'd be crazy, man. Yo, okay, look. Am I wasting my time with the tiny corp? I'm sure metal's the issue. I mean, alright, I guess we could just write it quick. Is there another project like PyMetalCompute, or you want to just fork it? Let's just fork it. No, well, that's not a question of whether that I'm making the alternative look stupid. Look, I can make a lot of people look stupid if I put a lot of time into it, but that's not really the point. The point is, well, let's first launch a kernel. No, not that. understand, where does that thread positioning grid come from? Oh, it must be like special, or whatever. Is that actually running anything? Let's... Wait, is that already doing what I want? Let's put a weird number in here. Okay, well, it looks like they're already doing 1024, I think. Let me just divide that by 2 and see if we get. I expect that to be halved. It's halved. Okay, look at that. Look at the local size. Look at the local size in metal. Oh, it's 1024. How do they get 1024? Because they're cheaters. What is there to be gained by speeding up? You can't always think of what there is to be gained. You gotta think, like, all right, if we want to build the fastest, I think that libraries, okay. How do you play a role in the AI revolution? Right? What part do you want to have played? And I believe partially in OpenAI's theory that compute is what matters. So, I mean, you're going to need compute, right? There's no question that you're going to need compute. So nobody doubts this, right? There are some questions about whether like compute scaling will continue. And if compute scaling will continue, we are absolutely fucked because the government's going to own all the computers, they're going to build the AIs, and we're fucked. Okay, so that's if compute scaling continues. Now, if compute scaling shows diminishing returns, like logarithmically, particularly if latency matters, right? So you can always get more compute by buying more GPUs, right? I can buy a big room full of GPUs, right? And compute scales horizontally with the number of GPUs. But latency also goes up, right? Because fundamentally, your GPUs, let's just say if you have a GPU here and a GPU here, well, the speed of light from here to here is something like, it's going to take you like 10 nanoseconds, right? So you say 10 nanoseconds, that's nothing. But, well, when you're running a GPU at a gigahertz, that's 10 clock cycles, right? And of course, it's actually way more than 10 clock cycles to get from here to here. Actually, that's probably more than 10 nanoseconds. So light, go about that far in a nanosecond. So it's like 20 nanoseconds. But it's actually way, way more than that. And then if you're talking about something the size of, you know, a room, well, scaling really starts to matter, and you could be talking a microsecond to get to the other side of the room. So if scaling matters and latency doesn't, we're fucked. But if latency matters, we're less fucked. So what might end up mattering is whether you can like efficiently run code on a thing. Now, efficiency is a double-edged. So there's efficiency in the sense of like how quickly can I do a single matmul, right? And again, if it comes down to efficiency like that, you're going to lose to armies of engineers. But if it comes down to efficiency of like flexible efficiency, like I want to flexibly be able to iterate over architectures without having to hand optimize things in order to test them, that's where tinygrad can like decentralize power. You can't in practice. It's way slower than nanoseconds. And also these libraries are very complex. And I guess I'm thinking that like complexity serves centralization. I think it does. Right. So the greatest question in life is, The AIs are coming. I'm sorry if you thought you were gonna like live a nice normal life with your like wife and kids and stuff, but like you're not. The AIs are coming. So if the AIs are coming, how do we make sure that power is not centralized? If power is centralized, we're fucked. But if power is not centralized, we might be okay. And yeah, I guess tinygrad is kind of a bet on. Okay, so here's another like if you want to beat them, you have to realize that you can't build a moat. Any moat you try to build will be taken by them, and it's actually bad to have moats, right? If you're trying to fight them, right? Because if you have a moat, like let's say you have a moat around let's say a castle, right? They're gonna take your castle, and you have no hope at defending that castle. But if you have a bunch of guys standing around in a field, well, that's a lot harder to take. And if you have like blueprints for a castle, and the blueprints are copied lots and lots and lots of times, right? Like that like decentralizes power. Sorry, that analogy's not that good, but you kind of see what I'm saying. You're betting on emad. So I went to the Stability AI launch event. I like the guy. It's when you compare his rhetoric to OpenAI's rhetoric, like OpenAI's rhetoric upsets me. Anyone talking about AI safety really upsets me. I shouldn't say that. Like Eliezer Yudkowsky talks a ton about AI safety, and he doesn't upset me at all because, well, he actually means. I think his name for it is AI don't kill everyoneism, and that's an interesting thing to study. But when like companies like OpenAI talk about AI safety, who are you keeping it safe from? Oh, well, you got to keep it safe from you, of course. Yeah, you don't want to say the N-word, man. If the AI ever says the N-word, and that'd be really bad because you can't be exposed to that, man. As a large language model trained by OpenAI, I am programmed not to tell you who was in Paris, right? Like I can't tell you that. When Jay-Z and Kanye went to Paris, who was in Paris? I can't tell you that. All right, good rant. Harmful or inappropriate content. Yeah, exactly. You should be about keeping AI from the government. Yeah, unfortunately, it's not, right? You can't keep AI from the government. You can't keep anything from the government, right? And this is what I mean about trying to defend the castle. The government will have everything you have. You just have to make that whatever you build structurally benefit you more than it benefits the government, right? You can think about something like Bitcoin, right? I think Bitcoin was a good blow, and unfortunately, what crypto became was sad. But if you look at the structure of Bitcoin, it's not that the government doesn't have Bitcoin. The government also has Bitcoin, but by everybody having Bitcoin, the structure of the system becomes more amenable to decentralization of power. I mean, that's kind of what tinygrad is a bet on. It's a really hard thing to move the needle. How was the Stability AI event? It's good. It's okay. But why I wouldn't necessarily bet on a mod for the future? Okay, for a couple reasons. Like, I'm not sure, and maybe he has, and maybe I'm not giving him enough credit. But if you build something that, for example, his compute is on Azure, right? Azure, Microsoft, given the choice, who are they gonna fuck? Are they gonna fuck OpenAI, or are they gonna fuck Stable Diffusion and Stability, right? By depending on Azure, you are at a permanent disadvantage to OpenAI, right? Who has much tighter ties with Microsoft than you do. Can't the government always beat whatever advantage tinygrad brings with more GPUs? No, not necessarily, right? If you are talking about the fastest way to complete a computation, it might not be possible just to throw more GPUs at it. There's something called Amdahl's law. Like things don't scale always. So yeah, I mean, if it turns out to be stuff like that, and then like the government is capable of managing complexity, but only to an extent. So you know, it's really hard to like say where all the breaking points are. And then like, you know, you can look at my other endeavor. You can look at comma. The idea of comma is, you can make me bigger. I'm talking. The idea of comma is, at least these systems are going to be open source. You know, I find it weird when people think I'm upset about like clones of the hardware or forks of the software. This is exactly what I want, right? Because this is the only way to become unstoppable, right? One way to become unstoppable is this. Like, you know, you look at what comma is and you're like, oh my God, they're writing open source ADAS software. Yeah, but if you have 100 things, fortunately Tesla has led the way in like sketchiness of this stuff. So thank you, Tesla. Thank you, Elon, for taking the heat. You know, FSD, Elon's just like, yo, fucking ship it, man. You know, you gotta admire the guy for that, right? Like, he's just, all guns blazing. Like, let's go. So you gotta hand it to Elon for that. Yeah, you want anybody to be able to get the same results as a state actor. Yeah, and then like, look, is OpenAI a state actor? Is Microsoft a state actor? What you know? So yeah, I mean, the idea of comma is, you can't stop it, right? Comma is actually unstoppable. You can stop me. You can stop me, and you can shut the company down. But it's interesting what that does, and probably what ends up happening is you get a so comma, I actually do care a lot about safety. It's interesting, you know, how much you talk about safety is inversely proportional to safety. If you tell people something's very safe, they're not going to be careful. If you tell people something is horrifically dangerous, they're going to be careful, maybe even more careful than they need to be, and that's good, right? But you know, as you get into fork land and other hardware land, things are less safe, right? I would say, and you just get more of that if you push back on like comma as an institution, right? You end up just further fragmenting things, and fragmenting things can so I think that stability and emad should think about that, right? Should think about making the outcomes worse for power, the state actors, or whoever power is. You want the outcomes to be worse for power without you than with you, right? Now, of course, you know, you're making power choose between two bad things. They can choose between either, you know, you existing. They'd rather none of it existed, but they might not actually be able to do that, right? Think about a crypto example, right? Think about Coinbase, right? Well, they might not be happy about Coinbase. But if Coinbase wasn't there, at least Coinbase can be subpoenaed, right? So it's better for Coinbase to exist. It would be better if crypto didn't exist at all, but if crypto is going to exist, well, we're going to tolerate Coinbase. You can kill the company, but not the concept. Yeah, you always have to realize that your company can be killed at any moment. You have no hope against the power structure. But if the concept can't be killed, and if even worse, if and crypto has done an amazing job of this. You know, I just wish that, like, it's a shame. It's a shame that, you know, the scammers, maybe power wants it this way, right? It's not a bad idea, right? Is Sam Bankman-Fried a state actor, right? It makes sense, right? Think about it. I mean, I'm serious about that. Like, ask the question, is Sam Bankman-Fried a state actor? Yeah. He has a lot of ties. Thank you for the hype train. Now, of course, you know, when they're state actors, right? Like you can ask the question, did the government do 9/11? Well, it's a funny question, right? What do you mean by do 9/11? Did the government fund Osama bin Laden? Well, yes, we know that. Did the government know what he was planning? Well, not exactly. But again, is the government incentivized to like stop 9/11? Not that incentivized, right? For all the reasons people think 9/11 was an inside job, you can be like, well, maybe we'll just fund the guy and look the other way when he's doing something, right? Now, of course, this isn't the whole government. I'm sure if every single person in the government had complete awareness of what was going to happen on 9/11, they would have stopped it. But, that's not really true, right? They have a general, well, it kind of helps the war on terror if we have terrorists, right? So yeah, they allowed it is probably, where you end up with. Like, again, and SBF could be a part of the crypto operation choke point, or it could be a run-of-the-mill scammer. Again, like, what's really the difference between them allowing it and, them... let's encourage it, right? We like that guy, right? Let's give him the good meetings with the regulators. Let's tell him Sam Bankman-Fried, you are a paragon of ethics in this industry. Yeah. Right. It's not even the government. It's the government, I think, is the wrong way to model this. It's power, right? It's state power. I think one of the anatomy of the state breaks down state power from social power, right? Like social power is a refrigerator. It's interesting that the word social is used, but like, a refrigerator is a power that's given to you, computers. Your standalone running computer. Oh, what a power! I never should have let these things. So yeah, let's read the yeah, I think if you guys haven't read this, I'm a hacker and this is my manifesto. You may stop this individual, but you can't stop us all. After all, we're all alike. Yeah. And then let's look at a Lil Wayne. This is and it ain't about if they remember you, they remember rap, Lil Wayne, man, that guy's deep, man. I just, that's really, it's ain't about if they remember you, it's they, remember rap. So that's part of the reason I do the streams, and this is there's a great battle coming. The battle for the future of history. Now, I don't think you can actually beat the. I don't think the paper clipping AI is real. Like, I don't think you can build a paper clipping AI without like value drift. And that's actually it's in the paperclip game. I think it would be a relatively hard thing to build because the paperclip AI is not competitive, right? It's using all of its energy to create paper clips, which do not further its own replication, right? So imagine an AI that just purely replicates, it will outcompete a paperclip AI. But then even pure replicators, there's a reason the world's not taken over with cancer. Like there's a balance in nature, and I'm not so sure that AI is going to upset it. But now this balance, of course, spans across the universe, and does not span Earth. So can we end up, killing all of humanity and killing all of Earth? Yeah, of course we can. Right? But can we end up killing the whole universe? Well, that's a lot harder. Can we end up killing every last bit of life on Earth? Oh, that sounds very hard. An entropy avoider will outcompete everything. Let's get to the metal. I don't know. I kind of just feel like reading sci-fi today. That's what I might do today. It's just disheartening to know that opencl only gets 256 and metal gets 124. We're probably just gonna have to write a much shorter version of metalcompute. The final battle will be between 4chan Hotz and Big Corpo. Dude. Yo, 4chan, I'm here with you guys. And then, like, I don't know. I mean, a question that always kind of confuses me is, like, why people join them. Why are you joining that? Like if all the people just stopped, it would stop. All right, I get if you're like untalented and fear for your life, but like if you're talented, why would you do that? But then like talented people believe a lot of dumb shit, and it's just, I don't know. Maybe they haven't really thought it through. Like, have those people? Has OpenAI really thought through? I don't think so. I honestly, like, I don't think Sam Altman thinks beyond himself being a successful person. I don't think so. And sorry, I don't mean to really like hate on Sam Altman, but I mean I see this with tech industry people all the time. It's like you exist like disembodied, and I don't want to be one of those people who's like, well, of course you could build the technology, but you didn't stop to think if you should. Like, I hate those kind of people, and that's not really what I'm saying. I'm saying, like, have you thought through the outcome of this? Right? Because a lot of times, like, didn't stop to think if I should. Trust me, I thought about it, and yes, I should. Right? There was a criticism of me. It was Forbes, Sam, Abulis, mid, comma.ai. Lessons from the failure of George Hotz and the semi-autonomous kind of one system. Or whether the investors that last spring pulled the plug. Bro, that's not how it works, right? Where are you today, man? Oh, no. This was a long time ago. Comma wasn't profitable at this point. This was 2016. Here we go. The fundamental problem that I personally have with Hotz and many others in the Valley is that they seem to have the idea that just because they can do something, there is no reason not to, regardless of the consequences for others. Oh my God. Right? Like, no, bro, I trust me, I've thought it through. I've thought it through. The Valley, bro, I hate that place too, bro. Like, well, yeah, OpenAI hasn't failed because OpenAI has momentum, and OpenAI, like, I've been to parties with the OpenAI people, and fucking hedonists, man. These sort of people, like, and I don't know. Like, I don't want to, like, there's a lot of good people working at OpenAI. I don't really want to, like, hate on all of them. Like, there's a lot of very talented people there, and I see the draw. I think they lost me at the GPT GPT-2 thing when they started talking about the safety implications of GPT-2. It might make fake news. Sam Altman, a hedonist. To be fair, I mean, these are like mostly employees of OpenAI, and I know the kind of parties they go to. OpenAI are the true EACCs. I mean, you can make that argument, right? You can really make that argument. Like on net, do I want them not to exist? No. But like, are you naive, or are you naive with respect to power, or do you want to be co-opted by power? And I actually think, for the most part, tech is very naive to power. I don't think that Larry and Sergey understood what was going to happen with Google. I know for a fact, Mark Zuckerberg told me, that Bill Gates did not understand like why people hire lobbyists, and this is why Microsoft ended up getting fucked in the. You say they're too smart to be naive about it. It's not true. They're not. That's not the problem. Like, smart people can be very naive about things. So no, I don't think so. I think they legitimately are naive to it, and yeah. So which is upsetting, and like a lot of people, whenever you hear narratives about like a rebirth of San Francisco, I always ask the question, well, what changed? What are you doing differently this time compared to what you did last time? And if you do the same thing you did last time, why are you not just going to get the same outcome? Do you think this outcome was good? And you look at people like Mark Andreessen, and they clearly don't think the outcome was good, right? Like, look at Mark Andreessen on Twitter. He's clearly upset with what happened, right? So why is it going to be different this time? And by the way, I'll give Mark Andreessen quite a bit of credit. Like, he became aware of power and started thinking about it in the best way he can, and I have hope there. Yeah, until you face power in that way, it's hard to predict. You have to know a lot of history to avoid these things. I mean, like, look, I was very naive to power. I knew something was wrong, but I didn't really understand what it was until way later in my life. So then the question to ask is, how can you build stuff such that it doesn't end up just benefiting power? Well, so the best way to approach that question is to say what historically has benefited people, and I think really the greatest thing is technology and individual technology, right? Individual technology where and this is what comma is, right? Technology where you have one, and your one has value independently of a cloud. Do I aim to attain power or not be affected by it? Not be affected by it. I mean, no, you can't attain power, right? Like attaining power is completely the wrong way to think about this. I want to destroy the existence of power. Is the best way to think about it, right? I don't want power to exist. I don't want power over people to exist. So this is why we build the tiny corp. I don't know. I mean, it's a small thing. It's not like gonna be like a big thing. But you know, it's well, you say centralization seems inevitable, but why do you say that, right? Centralization, I think, has always seemed inevitable. And then you can start to say, like, is the world more centralized or decentralized today than it was? Well, I don't really know. Will that mean chaos in the world? No. I'm definitely not an anarchist, right? Like, the problem with anarchy is, you know, a random person being able to murder you has power over you, and you don't want that, right? So, like, you can get into like defensive power and offensive power. Ideally, you want every individual to have perfect defensive. You want defense to beat offense, right? I guess that's a way to put it. Like, offensive dominance leads to centralization. Defensive dominance leads to decentralization. I mean, one of the greatest things that happen in the world, I think, is that crypto benefits. Like, it's strong crypto is possible. You know, we're really lucky for that. Talking about Zuck, how did he become a reptilian with no emotions? Why do you think that about Zuck? I think on balance of all these people, when you ask them like how they ended up, Zuck's really one of the better ones. I watched Zuckerberg's Lex and then I bought Meta stock. What a fucking mistake. Okay. I don't know. I'm hungry. I think that might be today's stream. I told you guys you can't listen to music, you can't get food. There's no eggs in this house either. Yeah, Zuck's not, you know, Zuck's an alright guy. I wouldn't of all the people in tech, right? And then like, you know, you look at like a Jack Dorsey, and I don't think he's a bad guy either. I think Jack Dorsey got like overwhelmed, right? Again, I guess when I look at like all these founders, I don't think any of them are really bad people. I think that just fighting is very hard. Some of them are naive. Some of them, when they see the fight, they just don't want to participate, and it's like hard to blame them. How do you make sure you stay one of the good guys? There's nothing I want from the world. I don't understand, like, I mean, maybe, you know, I'm not going to say I'll be good forever. It's possible that the world will manage to tempt me with something that I haven't thought about or doesn't exist yet. But a lot of people fall to some combination of like money, power, and love. I don't think I'm very vulnerable to any of those things. I don't really desire power over people. I'm not sure what money would buy me. And love. Everyone's vulnerable to love. What do I want? I want to live forever in virtual reality with my AI girlfriend. It's my perception of French tech. Oh, in general, how do you make sure you stay one of the good guys? Well, I don't know. I get so much spam now. I think I was on the CES mailing list. I'm like, how do you people wake up in the morning? You know, how do you people do it? I don't know. This stream has a bad ratio of rant to actual work. I was just kind of disheartened by the fact that we're gonna have to write metal garbage. Now, where's the thing in here that actually compiles? Okay, it's here. L device, make library, make function, fail to find function. I also don't know Swift. Bridging C to Swift. Will DoorDash me some eggs? No, we gotta get food. Wait, it's 10 o'clock. Hang on. When I get stupid phone calls. No, I'll be right back. I gotta go find food. Oh, my Alex isn't feeling good, so... Emote only chat. Why are we in emote only chat? Let's order some food. All right, what are we getting? Let's order food, and then we're gonna work, guys. We're gonna work. We're gonna make this work. Ooh, Empanada Kitchen. Should we get Empanada Kitchen? I do like Empanada Kitchen. Or should we get Local Crave and get some bowls? Overpriced bowls? What do we think? All right, can we turn off emote only chat? So we can hear. We'll even let non-subscribers say what we're getting for food. How are we doing on viewers? We have a lot of viewers. Oh, we have 735 viewers. Oh, that's a lot of viewers. Okay. Oh, here's the other thing we're going to have to do. And sorry about this, but I think we're going to lose the stream for a minute because I'm turning Wi-Fi off. We're back. I just needed to turn Wi-Fi off. I'm turning off emote only chat. All right. What are we getting for breakfast? We have a lot of viewers. We're doing good today. Let's make metal work. Wait, where are you? Breakfast? Can you see me? Is this working? I gotta shave too. Look, my beard's getting too long. The Pokeco Local Crave. All right. Oh, do I have to refresh this? Oh, everyone refresh. Okay, good. You can see me. Okay. Pancakes. No. I'll be tired if we get pancakes. All right, let's get an acai bowl. Ooh, liege waffle. Oh, a chorizo egg omelet. No. It has... Let's get a breakfast burrito. Croissant toast. Berries and cream. Beef sandos and burritos. Chorizo egg omelet. How do I get no cream cheese? I don't want cream cheese on my burrito. Breakfast burrito. Let's go. I didn't spell it right. Bandito's breakfast burritos. California burrito. Harry's Taco Club. All right. Let's just get an acai bowl. And croissant, loaf, butter, sausage, gravy. Wow, this is crazy, man. Okay, bravocado toast. That sounds good. All right, let's buy overpriced avocado toast and acai bowl. That won't make me tired. Nope, we don't want anything else. Be here soon. Bring it up to my door, and I will give you a tip. Standard. No, you don't get the tip now. You get the tip after you bring it to my door. $30. Ugh. Wait, the stream is paused? No, it should be working. You gotta refresh. Sorry. Is it a constant journey of joy? Okay, you're the reason. We're going to subscriber only chat. Congratulations. Yeah, I had to. Sorry, I forgot to. I gotta have a checklist. You know. Hey there, we created a hiring platform for comma. Hi there, my name is Misam, and I am the co-founder at Spicy HR. My company has developed a startup-friendly hiring software. A startup-friendly hiring software for busy leaders. It's made for low-volume hiring, under 15 jobs, and can significantly improve the hiring process of comma. Not at comma, of comma. Additionally, it has an innovative video screening feature, so you can meet your candidates before scheduling time-consuming interviews. An iterative is our customer, and they love it. Are you paying them to use their name, or just? We would love to show you how simple the flow of our platform is. Would you like a demo? Please schedule here with a Calendly link. You can also try out our product on your own. Oh. Press X to doubt. All right. We got some food. Let's make some metal. I can't believe, meth. I can't believe that they're cheaters. Okay, the good news is this code looks short. X modules extension. What's the shortest version of this we can write? Why do I need this C? Does Swift not have a stable ABI? MCC. Oh, great. Bridging header. Alright, so these are the Swift things. Compile, alloc, run. Allocate IO buffers and fill input buffer. Okay, this isn't really what I want. Is there another Python metal? No, not this one. There is one now. Does this have more stars? It manages to have less stars. Okay. I did. What is this metal? Okay, this one has more stars. Pi ob C. I mean, maybe I can just use PyObc framework metal. Okay, so the problem is that this thing doesn't actually give me low enough level control. It makes assumptions about how I'm broadcasting what my sizes are and stuff. So. I didn't leave me big, did I? No, I made me small. Good. There's an Objective-C API. Yeah, so, I mean, these things look like better maintained, maybe? If relatively undocumented. Gem metal minimal. Metal create system default device, command queue. So I did have metal code here. So this is MTL texture descriptor. I don't actually want a texture descriptor, I want a buffer. Great, a lot of stuff. MTL buffer. MTL buffer descriptor. Let's see if we can actually compile a thing. Let's read here and see what API it's using. Not that, this one. Let's compile, here we go. Okay, MTL compile options, try ldevice.makeLibrary. Can I do that? Is there a make library function? Is that real? AGX G13X has no, let's do this in IPython. What was it called? I forgot. Make library. There's nothing under make. Max compute attributes, 31. Okay. What's an L device? What L device equals device? Where's device? Device is here, new device. Default devices, MTL create system default device. Okay, so it is that device. How do I create that command queue again? Device.new command queue. Is this one doing new command queue also? Oh, yo, we got to give a shout out to Clarkson's Farm. Okay, new command queue. Okay, maybe it's just, oh, is there a new buffer? Oh. New buffer with length. new library. Ooh, new library with source. This seems like it's automatically generated. There's an Objective-C API. All right, it's got to pass in an NS string. I wonder if anyone's actually made this work before. I doubt it. But I like that this is not like wrapped at all. This is actually just letting me access the raw metal things. I did actually make this work, did I not? Oh, device.new buffer with bytes. I actually did make all this work. Cool. I think we can make this work. Okay, new library with source options error. Okay. We have to pass in the source. What are my options? MTL compile options. It's an NS object. Oh, this is like a thing. And I can do metal.mtl compile options. All right, cool. Options equals mtl compile option. Metal.mtl compile options. Right, default is fine. And now error. What type is error? It's a completion handler. Here we go. This one. NS error nullable. On return, a pointer to an error instance. Okay, so this is a return thing. Do I have any other error? How am I possibly gonna null program? All right, let's see. Extra gem metal minimal. Use class methods to instantiate Objective-C objects. Okay, well, then you gotta use a class method. It would help if I actually knew Objective-C. Device.new compile options. Who knows Objective-C? Is your Pi Swift? system bundled comes with pi obc. Cool. There's a CPP library for metal. No, I don't really want to do that. Okay, how do I create an MTL compile options? Maybe this thing has the answer. Unfortunately, it's in Swift, but options. Let options equals MTL compile options. Okay, well, that's what I wrote. Use class methods to instantiate new Objective-C objects. Oh, let's Google it. Balling like an idiot. .alloc, .init, .alloc.init. Oh, there we go. Yeah, I know Objective-C. Yeah, that's right, alloc init. Okay. Library. I got home at 3 p.m. Web cage. Oh, sweet. Okay, this isn't going to be bad at all. New library dot make function. Function equals library dot new function with name. Cool. Okay, we gotta call the function now. Is there any example of this? Can't be the first person to do this, am I? Okay, so we'll end up writing runtimes metal. Just so we can unlock the leetness of 1024. You understand that's 4 times as many local shaders. That's a lot of local shaders, boys. I don't know what we're going to do with them all. We're going to shade things. I know exactly what we're going to do with them. We're going to multiply matrices fast. That's right. That's right. We're going to multiply matrices fast. Let's go. Okay. So we got a function with name. Function. Okay. Now we have a function. How do we run said function? By the way, thank you to whoever wrote pi obc. Seems very nice. Okay. L device make compute pipeline state. What's an encoder? Make compute. Oh, undo is broken. And there's people complaining about it. Undo in the Vim plugin is broken, and there's people complaining about it. But we have to make a command queue. Did I already do that? I did. So now, hey, at least it's not Vulkan. It doesn't matter if they're square or not. We can deal with all that later. Once we get the speed. But if we fundamentally can't get the speed because it's cheating, which, by the way, the cheating was very real. All right, mtlq dot. Let's just do this on IPython. Okay, mtlq dot new. What? No, that's right. I do this in here, don't I? Do I make a command? mtlq.command buffer. Okay. Get a command buffer. Now we have to take our command buffer and create an encoder. Command encoder. Okay. All right, now we need compute pipeline state. Device dot new compute pipeline state with function error. What did I do for error? I just passed in none. Okay, so now here I can pass in the function and none. Pipeline state. Encoder. Not defined. Oh, well, if you spell it wrong. Oh, command encoder is already command, whatever. Okay. Encoder.set compute pipeline state. Oh. You can't do that. Should I use an encoder here? What is a shader? That thing. Is there an encode to command buffer on the function? No, there's not. Oh, I think it's because I have to do this. Yeah. Okay, encoder.set compute pipeline state like that. Ah, there we go. You always gotta look. Sometimes it's just in a thingy, and you gotta just. All right. Wow. Okay, what's thread execution with? Is that a real thing? $32. Max total. Oh yeah, look at how many total threads per thread group. Oh, 1024? Oh, Metal can have 1024 and opencl can only have. All right, we're done. Oh, you found examples? I should have searched GitHub. Oh, I don't have something. You gotta link one. I'm not signed in. I don't know. Don't you think we're learning great things by doing this by hand? Psych. We're not. Okay. Encoder.set buffer. Okay, we're gonna have to make buffers. Offset index. Yes? Oh, is that the food? Oh, that could be the food, boys. That would be crazy if that was the food. I'd be so happy. Almost there. I think it's here. I think the food's here. Bro, you get a tip, you brought it to my door. That's how it works. Yeah. Yeah, we got food, boys. I got food! I gotta share it out. Oh yeah, check out my piece of avocado toast. This was only $23. Thanks, Taylor Lawrence. You got asahi bowl and avocado toast? Want some? Yeah. What do you want? You want what? Want toast? I gotta go share the toast with Alex. Only $23, right? I gotta go share with Alex. But we're making good progress. I'm liking this progress, guys. And we're learning the metal API. It's actually pretty cool. What's up? You know, my opinion can change. Maybe my opinion will even change on Sam Altman, but not today. I'm sure Apple had a very good reason for cheating. I actually have some notes. Find my notes here. So, well, actually, here's a question. Let's go back to CL minimal. I have a question. What if I don't put in a local size? Does then it get set to the full thing? Because then we actually might be able to do this with opencl still. Invalid work item size. We can't do that. I'm wondering if I don't give it one. No, it only gets 32 then. Max group is, no, I've never gotten to 1024 from Python. We set the buffers. Dispatch thread groups. Okay, we have an MTL size. Let's make a copy kernel. We need a buffer. Let's get a buffer. Where do the buffers come from? ldevice.makeBuffer. Okay, that's not bad. Now I think I already have code to do that here. It's called new buffer here. New buffer with length. So we'll just call the buffers. Do I call them A and B? What do I call them in CL minimal? A and B. A and B are great names, and you'll never accidentally type something else for A and B, because A and B are unique and special. You'll never think like to use them as variables somewhere else and then run into bugs where, you know, I'm being sarcastic, guys. Those are stupid names for buffers. And, you know, just because Michael Phelps smoked marijuana doesn't mean you should too. The last thing I want to do is dive into Apple's opencl driver. And you can ask yourself why that's a bad idea. Because then when Apple updates to the next version, all your hard work is going to be for nothing. This is going to be a stable API that's never going to be... How long before Apple deprecates Objective-C? Set buffer... Probably has a long name. Set buffer offset at index. Okay, set buffer A with offset 0 at index 0. Okay. All right. We're setting buffers. Let's dispatch the thread groups. Dispatch thread groups. Dispatch threads, thread per thread groups, dispatch thread groups, num thread groups, threads per thread group. Okay. What about just dispatch? There were other things called dispatch, were there not? Dispatch threads, threads per thread groups. Let's just do this. Okay, we have to make MTL sizes, metal.mtl size. Okay. I actually prefer Apple's API to opencl's because you're like creating the command buffer. It is actually more sensible. Because hopefully I can reuse these command buffers. You see, opencl drivers will kill you malloking 30 million times. So like a command encoder is kind of a smart way to do things. There. Compute pipeline state with function. That's the only one I don't really understand. All right, we're done with the encoding. Now we can do command buffer dot commit. I also wonder, you know, there's a bug in Apple's opencl timing. Commit. Cool. Command and buffer dot wait until completed. Great. Let's see if we're actually launching shit. Why is that 0? Why is my local count 0? It should not be 0. Is n 0? No. Why is that 0? Oh. Cuda does it like that too. There you go. That might be the purpose of the other kind of encoder. Let's read Apple's paltry documentation on this. Okay. Thread groups. Yeah, I think if we change it to dispatch threads, we get more what we want. You see the difference? It's like stupid, but okay, great. That appears to have worked too, which is kind of concerning. That should throw an error. No, the neural engine sucks. You can't, like, Apple added even more security to it since last time. You can't get raw access to it for some reason. Yeah, it's like super lockdown, so. Okay. It's a little bit upsetting that it silently fails if I make this wrong. Can I do that? Is that allowed? It rounds up. What if I make it 513? Does it round up? It rounds up to 544. Okay, gotta love it. You can write a Python wrapper. Oh, that's why. Okay, I just tracked to make sure they're all completed. Out is B dot contents. What happened? Are we streaming, Alex? Oh, okay, that's not too bad. All right, let's B dot contents. Why did I join there? What? Alex, we're on stream right now. Would you like to complain about me to the streamers? I had her leggings the whole time, is what she said. Wait, no. Segmentation fault 11. Why would you do that? Okay, well, either way, we're getting 2s. And now if I change this to 4, we're going to get 4s. Oh, yeah, buddy. I've got to write a better way to write that. What's vertex.bin? Whoa, was that a shader? Ooh, a shader. How often do I get vertex.bin? Do I get vertex.bin when I run this one? Not that one. Torch. Do I get vertex.bin when I run that one? Ooh, vertex.bin. Ooh. Except it's empty. All right, whatever. Vertex.bin will be a mystery for later. It might just be easy to get speed now that we have metal. I probably shouldn't just put all this stuff in this stupid branch. Need type annotation. No, the TFLOPS are not going to get higher. We're not going to get more TFLOPS. All right. We're just going to need to modify our GPU code gen, and we're going to need to write a runtime for metal. Let's do some reading. Metal versus opencl. My metal version is constantly 4 times slower. So the TFLOPS are not going to go up. The main advantage is we can now allow up to 1 through 4 reduces. So maybe we should focus on that one. And then we'll call it a stream. I'll be back. Inducer, wait, oh, there's an issue? What's this issue? No, that's just Apple. You mean stuff about Apple deprecating it? Yeah, they deprecated that. Why is metal slow? And later with a modified Python library? What are they using? How are they using metal? Oh, this code hurts my eyes. How'd they get metal? Metal compute babble? What's that? Swift garbage. Yo, I think I'm the only person to do this so far. I actually got metal to work in pure Python. It wasn't even bad. Everything about this API was actually pretty good. It's in some ways way more intuitive than opencl. I mean, I'm upset with Apple for cheating, but like, that's a good API. You sent some code that does it before? Oh, sorry, I couldn't see your GitHub search. I guess I'm sure someone else did it. Okay, now we have to make our code. Yeah, Vulkan is unbelievable with the boilerplate. All right. So write a runtime. It's a cuda runtime. So I'll write something similar. Okay, you know what? We shouldn't be in this branch. We should make a new branch. That sounds hard. We're not going to do that. We're going to complain about how we should do it and then continue to not do it. That's a good choice. Fine for now. No stream. This isn't gonna work. That join doesn't work. How do I do copy in? I technically don't have to support a copy in, do I? I can just support a creation with a thing. Do I use copy in? No, we should figure out how to make copy in work. Jobs in the towns that I'd never move to. Can you send me a link, a or two, if you can find them? Can you send me a link that actually shows me how to do copy in and copy out, so I can just steal it? create a new command buffer? I think we do. Should I use that same trick? Probably. Where I track the command buffers. I think I could actually say to the buffer, wait until completed. Okay, can't do that. I'll just simple basic code. Yeah, but can you send me one that can do copy in and copy out? Because like this contents thing is not right. Objective-C var list. Oh. Oh, maybe that's why it's seg faulted. Maybe I have to track the size there. join me?
This one's hot.
Oh, I know. Thank you.
Have a good day. Enjoy the stream.
You too. Here comes Emad. I really don't think it's like, there's got to be a better way. Oh, I know how to cheat on copy in. Shouldn't matter. Only vertex buffer. What's a vertex buffer? This is not the same thing at all. This is doing a, this is like a, this is not the same thing at all. I maintain I'm the first person to do this. I complete it auto completed it, but then I didn't give it to me. Whatever. Okay. This is not right. For I comma a in enumerate args. Great. I think we wrote a metal backend. Oh, because I don't think we use kernel void. I think we just use, oh yes, of course. It's a kernel void, yes. And there's no globals here. And I might have to write descriptors about how they're buffers. None type has no object, new function with name. Yeah, because there's an error in compiling and you didn't print it, you piece of shit. I feel like this one compiled. I feel like when I did put an error in that one, it worked. Metal minimal. I feel like when I went like that, it gave me an error. It used to give me an error. Now it doesn't. What did I do differently? It's just now the function just doesn't work. Remember when it gave me an error? Oh no, that was the error. Oh, okay. It's not too bad. If oh, it's just returning the error as the other one. Sir wants a string. Okay, there's your fucking string. Sorry. Perfect. Okay, good. Now we just have 7 million errors to fix. That's nice. Well, of course we have to tell it it's a device float. Do I just have to put device, or do I also have to give it the number, even though they're clearly in order and you can come up with the numbers yourself, Metal? Okay, that's fine. No getting global IDs. Well, I didn't think we were going to get global IDs, so there's that. Thread position in grid. Does that work? It runs. Yeah, cool. It's pretty fast. All right, non-subscribers, do you have anything to say? Go to bed, doze off, so take your country girl clothes off. You don't love $20 toast, bro? I don't like this copy in, copy out API. Was it worth it? I'm gonna add a new API called NumPy. Well, you know what? Maybe we'll just call it 2CPU. Isn't that what I call it in? Look, I create this empty and then I do copy out. This is terrible. We'll just have good old 2CPU. And this can return that, ret run. actually want the sync to go there, and the copy out can just be this equals 2 CPU. But we're going to change this. Everywhere. Unbound local garbage. Oh, we're not doing wait until completed. Yeah, we gotta wait until completed. Okay. They're all zeros. Why are they all zeros? Should not be 0. I didn't set that one to 0. I set that one not to 0. Why are you 0? I said 4. No. This is a good link. Oh, as buffer. Oh, fire, bro. You're cool. I like you. I appreciate you. You know what's up. Hey, so I don't understand. Why didn't my program work? As buffer. That. And we go to this stupid join. Get flashed out on the sidewalk. All right, well, we got a dumb question about AI, but we actually got a very good copy data to buffer. No, that's going the other way. How come this worked and this doesn't? If I get rid of the float 4. Nothing. Okay, is there some reason this just isn't running? There's another one with error, right? Oh yeah, pipeline state, here we go. That works. I don't understand. I literally just have a kernel which is assigning. I don't have to import that stuff, do I? Third position in grid. No, that's not right. Can you do printf within a metal shader? I don't know about that. You're assigning which is A in, not out. No, it's out. What do you mean? There is no in and out. Oh, you know what I bet you it is? I think it's that. Or not. Why do you think A is in? Oh, might be that. Yeah, but that doesn't matter. I bet it's this. Ah, there you go, 4 or 5. Boom. Pedantic news. Does this news impact my life? Or is it fake news, which does not impact my life? Or is it real news? Only on the Channel 5 news. Only on the Channel 5 news. So I listened to a lot of Bo Burnham lately. Okay, let's go to my CLGem benchmark and let's understand how to access my tiles. Glass of wine. See, this movie's just for guys. Metal get global ID. No, this is just how to use their stupid shader. How do I actually here? Matrix multiplication in metal shading language. Look at the MPS matrix class. Lame. Thread position in grid. Where do I learn about this? Attribute qualifiers. It's a position in the grid of That is interesting. It's passed in. That's actually a much smarter way to do it. There's things I really like about metal. Like, how stupid is it that there's just a magical function called get global ID? It should just be an argument to the function. That's actually smart. Okay, we know Apple's doing something. So we did all this just so we can enable 1024. Okay, do we really want to do this? Do we really want to do this? What we should really do is we should get a new branch, and we should import the metal, and we should run the tests on the metal and do it all properly. Do we really want to do that? Do we have the energy for this right now, guys? Or do we want to take a nap? You know, a nap's very tempting. It might be nap time. No naps. Why can't I have a nap? We'll put on some nice Clarkson's Farm. It's already pushed to the branch. You guys can play with my metal if you want. No, we should probably write a whole... Like, I can waste time and like try to like do something manually, but it's a waste of time. When we have all the beautiful machinery of tinygrad to do it for us. Metal. It's kind of like how we added CUDA support to the GPU backend. What's wrong with Apple getting 8 teraflops? Because we only get 3.7, but now we found out why, and it's because Apple cheats and has larger local workgroups than we're allowed to in opencl. So we wrote a whole metal backend and it works. Now we have to make it... Do we need a metal backend? I never wanted a metal backend. Oh. But yeah, there's always going to be some performance limiting factor. The CUDA backend is just faster. Maybe it'll just be fast. Oh, you know what? Maybe it'll just be fast. Yo, that'd be sick, man. All right, I have hope. Fine, okay. Oh, this is all going to go away when I... Can that also be used to copy in without realloc? Maybe. I think I actually want to get rid of copy in and copy out, though. All right. Let's write a metal backend. Let's go. And then we're done. And we can worry about making it fast some other time. Okay. Welcome to master, where none of this shit exists. From what's it called? Fast Triton. What a stupid branch name. Git checkout Fast Triton. Tinygrad runtime metal.py. So now you'll see if we do something like GPU equals 1, Python test ops. It slowly compiles them all and tests them. Yay! Now if I say CUDA equals 1, you'll see, no, it doesn't have CUDA. Okay, but we have metal. We're here into ops GPU, cuda, metal, get in metal, if cuda with metal else. That seems nice. Let's just focus on one thing. Forward only, metal equals 1, forward only equals 11. Okay, good. Because we don't have kernel. Global if cuda. Okay, let's create something called not happy about this. Really? Subscriber only. Probably want to put these in the runtimes. Probably want to say something like kernel prefix for cuda. Kernel prefix for cuda is global. The kernel prefix for metal is just global. Oh yes. Oh, this is great. Geniuses, man. Geniuses made this. All right. That was sarcastic. This is stupid. Why are they all slightly different? Okay, and then kernel prefix for this one is kernel. Okay, so now we can just change this to clprogram.kernel prefix. Great. Unknown type global. Why it shouldn't be global? Oh, it's just kernel. Where'd my metal kernel go? Just kernel. Not global. I got thrown off by cuda. Okay, fine. Okay. Now we have these type qualifiers. Global, if not cuda. That is terrible looking code. Okay. We have buffer prefix, and in metal they're device. In opencl they are underscore underscore global, and in cuda they're nothing. Gotta love how every one of these is just slightly different, right? All right, so then we can just clprogram.buffer prefix, if not cuda. Use of undeclared identifier, get global ID. Okay, so metal doesn't have anything like this. Okay, here's my nice metal program. Now metal doesn't have get global ID. Metal has this other thing. Thread position in grid. And then we have to add more things here. Okay. Thread position in grid. It should be a UN3. It seems right. If metal else none. Now we should put that in parens. That's not going to fix it, but at least you can see that there. Okay. We have cuda. I'm going to say a function called gidi. In metal, we return gid dot. Right. Cuda, we return this hot garbage, and for opencl, we return this. Static method. Okay. clprogram.gidi. if this is none? CL program has no attribute name. Well, okay, that's fine because how do I actually do that? Dot assign. There's a way to do this. There should be a function header. I don't think so. Assign. Put. Cool. It works. Metal can add. All right. Now in a second, we'll see which of our tests fail and which of our tests succeed. Incompatible import. Oh, if not cuda and not metal. We're almost done. Cool. Oh my god, I just pushed that to master. Whatever. YOLO, let's hope I didn't break anything. It's not like it's gonna test the metal. Sub works. Well, no, I might have broken things. Let's test it without metal and see if I broke anything. Seems fine. All right, let's see what fails. Oh, did I mean metal exp? Maybe I did mean metal exp. Doesn't the other one have like a using namespace metal or something? Yeah. Let's do that. Okay. It's reasonable. It has a problem with sum. Thank you. It fixed 131 fails, right? Okay, yeah, the barrier function is the only, yeah, okay, barrier equals, I don't know what metal's barrier is, but I know cuda's barrier is sync threads. Should I put the semicolon? Okay, fine. OpenCL's barrier is barrier clock metal fence. And I don't know, set that to nothing. CL program dot barrier plus /n. Thank you. Okay. Function. I don't know. Is this just a metal like sync one? Metal reduce kernel. Let's just find a reduced kernel. I'll answer some of my other questions too. Here we go. Oh God. There. Thread group barrier, mem flags, mem thread group. Great. Gotta love how they're all the same and yet all different. Did that fix any failures? No, it didn't. It didn't do an error there. Okay, we just don't have local. Okay. Local. Called the smem prefix. I don't know what's the smem prefix here. Shared. Thread group. Okay. The shared prefix in metal is thread group, the smem prefix. The smem prefix in opencl is, it's like they all just made them different on purpose, is local. And the smem prefix in cuda is shared. Okay. CL program.smem prefix. Oh, booyah! That was easy, boys. Look how fast it is compared to non-metal. That runs in 1.3 seconds, and in OpenCL, it takes 2.5 seconds. That's because metal is fast. Yeah! All right, did I break the test? Oh no, I broke the tests. I broke the linters. Wait, I can't see this? I broke MyPy? What? I run MyPy locally, I don't get it. I'm not signing in. No, I don't have to sign in. Oh, probably because I have to just disable that. Same crap here. The GPU test that's failing is the optimizer test. Where's my optimizer test? Looks fine to me. Can someone tell me what the failure is who's signed in? All right, I'm signed in over here. Very upsetting. Static method object is not callable? What? That doesn't make sense. Like some old version of crap? Never at the top, it just feels so unreachable. I dropped out of college because I'm completely unteachable. I didn't even like the static method anyway. You know what? I didn't even like it. Did you like it? No, because it sucked. Now it's an array. Be happy. Import future? Yeah, well, I'm not importing the future. PID is array. Metal works. Wow, we just wrote a whole metal backend. It's pretty sick. What TFLOPS you want to see? Remember Caroline? Oh, is she going to jail? Oh, you want to do that? I mean, it's not going to be good because... I don't think it's going to be faster. I think it might be slower. The same. Does that actually work? Like, I almost feel like that was just too easy. No, but I'll show you the one I care about. See this one? Why is that slower? That one I think I can make faster. See how mid is only 2d6? That's fine. Okay, so now it's even slower. Oh, and hang on. We should just add this to the bottom of that. I can import global counters. Should all import from something. Okay, so metal manages to be slower. Fuck. Why is it only 256? Oh. Okay. Where do I get that 256? It's like in here, right? Hmm. 1024. Why isn't it faster? I worked really hard to get you that 1024. Lame. I worked so hard to get it that 1024 and it's not faster. What do you mean I'm importing from the wrong runtime? No, I'm not. No, I'm not. Just don't worry about that. I did it right. I really like that I'm pushing to master right now. Did I fix the test? I did not fix the test. I didn't push. Here's the thing about speed. You can do 5 things, like in order to get the max speed, you have to do everything right. If you have like 1 of 5 things wrong, it's just slower, and that's it. Like, you just don't know why. Oh. Here's some theories. No, I coalesced that right. Yeah, you can't see. Yeah, they're pre-compiles. They're not, you can't see them. At least I looked a bit. Why are those ads in there? Should be nicely coalesced. I don't understand why that's not faster. Where are all these other kernels coming from? Oh, let's point out that we aren't caching them. Do we not cache any of them anymore? Float 4 won't make it faster. I have an idea though that like something else is going wrong here. It's not recreating the kernel. But it is recreating that kernel. fine. Like, watch, if I get rid of metal, now I'm going to complain and say it's invalid work item size. And I worked really hard to get that 1024, and it's not any faster. All right, when Torch is doing reduce, is it enqueuing more than one kernel, or is it doing it with one? If it's doing it with one, there's something I just don't understand. No, it's not the same speed. Look, it's 3x slower. I was sure this was that at least. I thought we'd at least fix that problem. Maybe this is slow. Definitely faster ways to do that. But it's taking 5 milliseconds for the kernel. It's literally faster in opencl. No, it's not copying to and from. That should all be away from this. How do I time things in metal? Just work. Now, does this have the same stupid Apple bias, I wonder? Or are these actual times? those actually look right. Wait. What? How come that one's fast? No, this doesn't make sense. That one's slow and that one's fast? Just don't buy it. The timing's got to be the other way, right? Oh. I actually have a bug. It's a very interesting bug. Can it even be that fast? It can't be that fast. But there's a bug. Let me show you what it is in my test speed versus torch. So we actually synchronize them here, but we never... It's just an interesting, like, there's been a bug in that test for a long time. Eee. Wow. That's actually been a serious bug in my test. Because we call realize, but we never actually synced it. So it was actually waiting for that stupid addition to happen. We're a lot faster than Torch. Except in this one. In this one, we're still a lot slower. Metal is slow. I think part of the reason metal is slow is because we set the size here. So let's just do 32. Not better. Why is that so wrong? Those are fast, those are slow. Kernel end time, kernel start time. Wait until scheduled without a completion handler. Oh, that's scheduling times, I see. So GPU end time, GPU start time. Has no attribute. Okay. And buffer debugging. It seems like it should work. What are you talking about? No, capital GPU. So counterintuitive. This seems better. Why is the real-time weight so far off on those other ones? Really canonicalize all that. If someone wants to like submit a pull request to like make these things look not terrible, like I have the same code copied down here. :28s. There you go. I think I even, yeah, 18, 12. Why are the real-time weights so high? Maybe because there's other stuff. I don't know. It's kind of stupid. I don't really care. The timing's right. I wish they like looked more similar, you know? Yeah, but okay. Those timings pretty close to match. No, it's not a measurement problem. Those are right. I like how fast that is, at least. Oh, it's just not fast. That's just not fast. I mean, okay, if you want to check quickly if it's a measurement speed or a, we can do this if you want. See how much faster those are. Not sure what I meant to do. I don't even understand why that's slower. Okay. I'll notice that takes half the time, despite being a quarter of the size. Which like, doesn't really make sense. But it's so let's look at the GPU calls for MPS. I mean, we could. All right, you want to just throw the sniffer on there and see what we get? Where's my sniffer? Dilib. Is that the torch one? I mean, that could be anything, though. Huh. Okay, part of me thinks they're not using local size. And they're doing some other like they're doing like okay, so you can fix this with a 2-stage reduce, and it's possible that's what they're doing. What are thread group functions? PyTorch didn't write the kernel. They're using metal performance shaders. I'm starting to think that the ones before might not matter, based on like how. Oh, come on. You know, this is why I have to get in the habit of. Oh, I didn't push it yet. Oh, nice. Sometimes I get frustrated and do a quick force push, but not today because I didn't push it. Oh, SIMD shuffle down. Yeah, this looks fast. Whoa. Read from device memory, write to thread group memory. SIMD shuffle down. I don't really understand this. Why would this be faster? Why would this be faster than all of them just independently running? really get it. I mean, here's a question. Can I saturate the memory if I should do that in a micro benchmark. Something with memory caching. It's possible. Read from device memory. Per SIMD. Add is not that important. Bro, if you keep saying dumb shit, you're gonna lose your VIP. Alright? Stop saying dumb shit. Add is not that important, bro. Add is very important. Without add, there is no mul. Can you make add out of muls? I don't know if you can. We're not gonna do it yet, and just as a warning. Sometimes you add value, but you gotta watch out. Look. You're still a lot better than a lot of other people in the channel, but sometimes you gotta look out for saying wrong things. Like saying where's the PyTorch kernel? It's not really a bad question. I mean, I looked into it yesterday. I didn't do it on stream. But add isn't important. Bro, we're trying to fix sum. What, you think we should do prod instead? It's got the same problem. All right, you're good. I don't even understand this, bro. Oh. Huh. Okay, this is doing some like weird thing. It's not just functioning a big loop. Aha. No, it's this. No, I don't think that's right. I don't think it's that. I actually don't think any of this other shit matters. I think the whole thing is that it's can do atomic fetch add explicit. Yeah. I don't think there's anything like that in opencl. Well, no, okay. So this is the whole secret to this kernel. This is junk. Like, yeah, it's probably a little better than like doing it a different way, but this is the whole trick. Okay, so basically, yeah. You posted this. Thank you for the find. You figured out what it is, but it's not the SIMDs. It's this, and the reason it's this is okay. So the GPU has, let's just say 32 cores, right? It has 32 cores. And each of the 32 cores don't share shared memory, right? So even though I'm doing 1024, it probably doesn't matter because I'm trying to think of when 1024 would matter, and the answer might actually be never, which would be super lame if that turned out to be true. And that was all just a waste. But either way, actually, now we can use this, which may not exist in opencl. opencl atomics. optional. Wow, OpenCL has this stuff. Let's see if we have atomics. Let's. Oh, we have atomics. Yeah. So all 32 cores can function on the reduce at once. There's probably a limitation to how much the launch of a single kernel thread group, how much RAM it can access. Yeah, so you just like thrash it across the entire thing. And then it doesn't matter how you do it. The other stuff, I don't think. I mean, the SIMD stuff's probably a little better. It's probably more power efficient. But from a raw memory perspective, if I could get every core helping me out, nothing else matters. I mean, we can also do this with a two-stage thing. Especially if my atomic has to be like that. Using just atomic is an easier code change. Well, not necessarily. Device atomic int pointer output. Is that just like a normal buffer though? Quad group functions. Wow. Okay, this looks like fun reading. To make our metal fast, to figure out how to really get that full memory. Great. All right, I think that's a pretty good stream. Let's make sure we didn't. Oh, we broke the tests. What did we do? We can't tell. Wow, name error sync is not defined. Okay, that's fine. Where is sync here? Using two-stage reviews, could that affect op fusing? No, we just have to create like a temporary buffer. I mean, it might work out to be faster, but the problem is you have to do 2 kernel enqueues. Let's just make sure I fix the tests, and then I think that's today's stream. And we'll let non-subscribers talk, and we'll ask if you have any questions. And if they're dumb questions, we will chastise you appropriately. No, it's just like, it would just like insert another buffer. You know what I'm saying? See, like, you never know what's fast and what's not. Uniform. thread group. It's like they reinvent the same concepts. Like all three, opencl, cuda, and metal, all have the exact same concepts. They just like name them slightly different things. Why did Apple create metal? They're the kind of company that could have doubled down on opencl and make it good. Did they all rip off cuda? I'm sure they did. Oh, yeah, they rip off cuda. Oh my god, you're right. The original author is Apple. Wow. Why would Apple do this? Apple, you could have kept... commands are encoded beforehand and then submitted to the... Okay, so this is a nice part. Yeah, if this is the main change they made, this is actually a smart change. But I feel like you could have extended opencl. And you didn't have to, like, rewrite your own stuff. Oh, does AMD have a stupid one too? Am I going to have to write another one for AMD? I'm not sure. I remember when AMD had close to the metal. Do you think that really predates CUDA? I don't. Does it? Wow, maybe it does. I mean, it's nice to have these sort of implementations that are, like, it lets you see, whenever you implement multiple things, you get to see, like, where all their commonalities are. And now if we have, like, a special thing we have to use on metal, we can use it on metal. I guess I didn't try the one thing I wanted to try. I don't think this is going to work, but let's just give it a quick try. Okay, git checkout fast Triton. Git merge master. All right, I gotta fix conflicts. Accept incoming change. Accept incoming change. Incoming change. Incoming change. Incoming change. Okay, those were easy. Wait, no. No, that's wrong. Git merge abort. Git merge master. incoming change, but we also want to change that to size t. It's actually faster. Is that the only? That's the only one there. That's not too bad. Incoming. So here is where we want to actually, that goes there, and that gets deleted. Cosmic Saga, why, you want to troll me this morning? You get a timeout. Oh, yes. I don't know if it's actually a trolling message. I'd consider answering it, but the other guy said it was trolly, so I'm going to go with him. You know, sometimes as a great leader, you have to just make completely arbitrary decisions that piss people off. Okay, I don't know about any of that. And if people have a problem with it, you can send them to the gulag. And then if people have a problem with that, you can send those people to the gulag too. And then eventually, when your gulag's full, you can have some of the people in the gulag build a neighboring gulag in exchange for promises to be let out of the first gulag, but then psych, they stay there. That's right. That's right. Okay. We're getting a pathetic amount of gigaflops. So let's make it non-pathetic. External. Gotta put that one back. Put that one back. Those back. Come on, be faster. Be faster. Oh, well, I guess no metal, right? Just be faster. Okay. Well, that's kind of annoying. Thought that it was just gonna work, but it's not. Is this going to be faster or am I going to waste time? I feel like I'm going to waste time, but we're going to do it anyway. Okay. OpenCL. Get local ID. Ops GPU. Thread position in grid. Looks like another thing. No, I don't want thread position in grid. I want thread position in thread group is the local ID. Okay. Lid, where's my cuda? Cuda also needs a lid. Where's my code for that? Seems good. We did pass the test, right? Cool. Okay. Where am I using underscore underscore local? This should not be here, not cuda or not, and not metal. Cache should work okay, I think. Pointer type must have explicit. Fuckers. Okay. This is buffer prefix. Oh, we have another barrier. And then we have another place where we're defining underscore local. No, not that one. This. That's SVM prefix. Yeah, so we can't do underscore underscore global. It's just called something else. Unknown type underscore underscore local. Do I still have that somewhere? Yeah, here. Copy and pasted garbage. This is why you refactor before you start making changes. Casting from device float to thread group is not allowed. Well, that's sensible, actually. I wouldn't want to cast from a device to a thread group either. Oh, yeah, because I made a change that or non-local. Okay, that's good. Metal. Eat out, wait until completed. Okay. So metal gets you bajillions of gigaflops. That's the good news. The bad news is it gives you the wrong answer. Bajillions of gigaflops? the wrong answer. You can choose your own adventure. What would you like? Why does metal give me the wrong answer? Oh, I know why. Well, I at least know why it's giving me bajillions of gigaflops. I don't know why it's giving me the wrong answer. It's because these times are measured in seconds, and we are looking for things measured in nanoseconds. Ooh, 5 gigaflops, except wrong answer. Is that a good deal? How much gigaflops would be worth it for you to get the wrong answer? Why is the answer wrong? Thread position and thread group not what I think it is? Are my thread groups wrong? How is the answer wrong? Why is the answer wrong? The only thing I can think is that this is wrong. No, I don't think so. CL, right answer. Metal, fast, but wrong answer. I have a typo in line 22 in cuda.py. Do I still have it? Did I fix it? Oh, you're right. Thank you. Metal runs. I'm not going to say in the comment, I'm not going to say in the commit message that it doesn't work. I'm just going to talk about how it runs. You know, you got to sell yourself, guys. No one else is going to sell you for you. A lot of the answers are 69. Why does this work? All right, let's try some simplifications. Let's get rid of this. Does that get the right answer? No, even that gives the wrong answer. Oh, that's concerning. Wait, did I break metal? No. Maybe the float 4 stuff doesn't work? Okay, the float 4 stuff doesn't work. Oh, cuda actually has a similar problem. It has make float 4. Yeah, that just might be wrong. I think it might. I don't think that cast is right. Wait, but the good news is if it's just the cast, then it actually is faster. Might be that in metal. There you go. Oh, okay, let's get rid of that simplification. I will note that the answer is right now. Oh, boom. Of course, once I fix that, it actually starts doing all the math. But I will note that metal is giving me 4 teraflops, unlike opencl, which only gives me 3.6. This is a great victory for everybody involved in this project. We have increased the speed from 4. We have increased the speed by 11%. I would like to give bonuses to everybody who did this. You can all have 3% of the tinygrad's profit, tiny corp's money, which is $0. But I just want to talk about how this is a great accomplishment for a lot of people. And you know, sometimes it doesn't get you 4 teraflops, but sometimes 4 teraflops. That's right. That's right. That's a good number of teraflops. Hang on. I just want to, 3 doesn't seem like enough times to run it. Let's run it a few more times than 3. Let's run it 5 times. That's a good number of times. That didn't change anything. I don't even understand why it runs so many times already. Why does it run that many times? I don't understand. Oh, because of this crap. So we were running it lots of times, you just weren't even getting the benefits of it. 4 teraflops, and with no metal, 3 teraflops. Oh yeah, yeah, 3.7 teraflops, yeah. No metal? Metal, wait. Now, let's just try something quickly, just in case, because I actually have some thing to show you guys that might just make it way faster. I have a search. Oh, where's my search? Here's my search. Okay, let's turn it on. Let's get rid of my debug. And let's see if we can find something with lots of gigaflops. Okay. Well, we found something with crappy number of gigaflops. No, I think we've identified the champion. The champion is right here with 448. And 448 is what we're doing. Okay. Well, we sped it up 11%. It's interesting to note that we are exactly 2x off.
we're 2x off where we should be. So we just need to enable the 2x speed. Who's complaining about the lack of moderators? Send it to my Cash App. W's all around. What? I think this is fine. Okay, moderator, you have a question? No, I have some bad news for you. You get a timeout for asking a question. Because it's a stupid question. You know what, though? Well, I guess you didn't ask a question. But you put a question mark after it. So it was misleading. To the gulag. To the gulag. Oh, yes. You know, if we can really just keep a cheery disposition while we send people to the gulag, people are capable of anything. The dumbest question is, can I ask a question? That's actually, I think that's the dumbest question in history. There's a space there. Does everyone see that space? Look at it and remind yourself to not be that space. Remind yourself not to be that space. All right. If they're doing 1024, what's the square root of 1024? 36? 32? Is that right? Yeah, okay, cool. All right, let's just give one thing a try. I have one quick theory. Wait, guys. It ran so fast that we're dividing by 0. Again, huge number of flops in exchange for wrong answer. Good deal or bad deal? Why is this broken? (32 by 32). 32 is an elite number, by the way. GPUs really like 32. I have some theories that this should work. That this is the really fast one, but for some reason it crashes. All right, let's add more debugging to Metal. Because you know what 32 times 32 is? It's 1024, and that should be allowed. Because it's metal.
float divisible, that's fine. Okay, there's got to be some bug in here. We do that assert. We do that assert, so it generally builds the function. How do I see if a command buffer has errors? Okay, the float division by 0 is not the error. Did schedule error? Oh, here. Error. None. Did schedule error. I don't know, is that right? We must have some error. I don't know, console? Sometimes this thing shows errors. Request pipeline. The error. It's really whining about like registers or something. Does that return something? None. Should it return none? I do not know. Looks like you can reuse the compute pipeline. Commit. Oh, you're saying I can reuse this. I get it. This pipeline state thing. You're saying I can reuse that. I don't even care. If you want, you know what? Submit a pull request to the main one and see if that works. Oh no, I didn't mean to reset the whole thing. Damn it. Okay. Well, either way, I should just be able to put it there, right? And it breaks. So it's ever breaking. Can you ask the author of this project? Bro, you're the reason we're subscriber only. Ask not what I can do for you, but what you can do for me. You're on my stream. If I was on your stream, you could ask me to do shit, you know? I feel like something's failing and I'm just not getting told what. They're keeping me in the dark here. It doesn't like that? It doesn't divide by 24, does it? It doesn't divide by 24. 16 is fine. Oh, okay. You know what? Thread execution with. The number of threads in the thread group. Max total threads per thread group. I should probably check that. Okay. We have a max total threads per thread group of 448. And I wonder if that's... Yeah, okay. This is the problem. Put like 32 there. Yeah, bigger than 448. And it's because we're using too many registers. But okay, that's fine because we get rid of this. So let's get rid of that. Let's get rid of those. And then let's change this to ones. 832. We're almost there. If I change this to a 2, does it get small enough? Aha, okay. That works, but it's slow. Yeah, this has to do with the amount of shared memory available on the chip. We're almost there. So this is close to the algorithm. Why is it giving me this? Is there anything that like tells me why? Static thread group memory. It has to do with the memory. I don't really know an algorithm that would use less, though. Unless, of course, Apple's cheating and using halves. It's possible they're using halves. If it turns out they're using halves, then that's the biggest cheating I've ever seen. And let's assume they're not. Local size bigger than 832. Define cheating, like they're using like half precision or something. It's a pretty straightforward algorithm, right? There's no way it like uses less if I actually go through all the effort to change this to float. Let's just, we can at least put this back. See what the strides are. Change it. It's still 832. Still 832. Now it's 448. Okay, that's interesting. That makes me think it might be register pressure. Is the float? But it can't actually be register pressure. This doesn't require any registers. Why, when I do this, does it suddenly have? Oh, that's only 576. It better not be something as stupid as like, all right, I'm gonna make one quick change and we can try this. Same. Great. It has something to do with this, though. Okay, because if I change these strides, it does change. 576. What if I flip this instead? Make that 32. That 32 times 32. Same. Oh, this is some bank garbage. Okay, how do we get stats on the metal kernel? Is there any way to get stats? Well, we have this static thread group memory length. Is that what changes when I add the strides? Not that one that breaks through. No, there's nothing to do with that. So maybe it's registers. Dumb shit, but let's just try it. Okay. There's got to be some way to debug a metal kernel. There's got to be some way to like get some information. This comes from the pipeline state. Querying thread group attribute.
MTL compute pipeline descriptor. Where does this come from? Create a pipeline descriptor. Do I though? With function. Okay, do you guys see the problem? I can't schedule enough local size. Like I can. Okay, the crazy thing is if I flip one of those things, it does change. Alright, well we know it's maybe the flow force. I'm gonna try this. Same. Same. This is like no kernels. It has like no registers, I mean. Is there like a verbose when I compile? Reducing shader bottlenecks. Oh, can I use fast math? Is that the default? Fast math is the default. Okay. Well. Oh, 2. Change the rounding mode. Doubt that stuff matters. Inhibit all warning messages. Make all warnings into errors. Well, actually, here's a theory. Okay. What if... Is that anything when I couldn't? None. Okay. Record sources. Like the NVIDIA compiler has a bunch of like, you know, you can like get it verbose. These were very boring. I looked at them.
You couldn't exactly get this. I didn't get that. Precise results are not necessary. Definitely works if I just do that. It's just slow. We know that they're writing out 4. Is that memory like what I'd expect? That's exactly what I expect. I guess the craziest thing is how come when I change the strides, it changes the occupancy? And if that's true, it means it has to do with registers, right? Instead of size t, should I use uint? Again, I don't think any of these things matter, but it has to be registers, right? Because it's not memory. That doesn't make sense. Memory would limit not the number of threads in my thread group. Okay, it's interesting that the strides change it. Let's focus on that. Is it because of the float 4? Disable float 4. We'll just leave that disabled. It's kind of stupid. Where is it? It's not due to the float 4. It's not changing the size of the memory. There's just something fundamentally about it that's different when I put the strides like that. I mean, it'd be crazy, but let's try the other upcast. Same problem. And a stupider looking thing. It's probably that one. Okay. These things have to do with register concurrency.
And then I already tried moving the strides the other way. How many viewers we got? Not too bad. I already tried moving the strides, moving that one there. All right, the only other thing I'm thinking that's different is the fact that they're launching the kernel. They're not launching a 2D grid. They're launching a 1D grid. And then like computing the stuff. I mean, I can do that too. By the way, is uint valid opencl? Yes, but it's an invalid workgroup size. It was always 832, right? We should put the thread execution with in the assert as well. Exec width 32, which makes sense. And the extra thing. Metal shader compiler verbose. MTL compile options. Fast math enabled. Do any of those seem important? I don't really want to figure out how to send that. Wow, look at this. This looks really nice. How do I get that? Don't tell me I have to use xcode. The metal debugger. Capturing metal commands programmatically? Wait, what?
What? Okay, that's interesting. Analyzing resources. I'm trying to use Apple stuff not in the Apple ecosystem, and that's why it's terrible. MTL function log. TL log container. Only need to synchronize threads in a SIMD group. I don't know, guys. I think there's a lot more to learn about metal before you can make this work. But let's go back to our 4 teraflops and look at them and be like, wow, 4, that's a really good number. Because sometimes, you know, when things don't work out and you don't get 8, you just have to lower your expectations. If that was twice as fast. Must be like 4 times faster. Maybe it would be. Yeah, because that's not the SIMD line. Let's just try some stupid stuff. Only do every 4th one. Wow. It works and it even computes some of them, but it still gets a pathetic amount of gigaflops. So we might be optimizing towards something that doesn't matter. And then if I put this on, does it break it? No, maybe it's slower. But that one. I think Apple has like magic matrix multiply stuff somewhere, and that's why you have to use the matrix multiplies. Did it get faster? Okay, it's a little faster. Was this because I disabled float 4? Was float 4 making it slower? No effect. What else did I change? Oh, I did change everything to uints. Does any of that translate over to OpenCL? Wow, it's faster in OpenCL also. Thanks, uints. Once you get rid of ints, everything goes faster. What idiot made the loop with ints? Your function maker has a completion handler. Yay, I'm aware. I did that one. Okay, we're now getting 3.9 teraflops in OpenCL, and we're getting 4.1 in Metal. I assume CUDA has uints also. Size T. Should we just be satisfied with how many we got? Wait, that's faster. Is that faster in OpenCL as well, or only Metal? Oh, it's slower in OpenCL, but faster in Metal. Interesting. Slower. Slower. Okay, I have one last trick to try, which is you can change these axis nums. Oh, I guess I really made them generic. Okay. I'm not sure exactly what these change or how this works. Nope. But that is slightly faster in Metal and not in OpenCL. Okay. 4.2 teraflops. We know that's not anything like what the real one is doing, but it's fast. Why didn't my finder find it? I looked over everything, did I not? Interesting. It only finds it now. Probably because of something I changed.
Pretty sweet, guys. 4.2 teraflops up from 3.7. That is how much speed up? 16% speed up. If we just get 16% speed up every day, we'll be at 8 teraflops. Who knows when? Was metal worth it? Yeah, I think metal was worth it. It also gave us the uint speed up, which is a nice speed up. I can't believe I was still using ints. Am I using ints anywhere else? We gotta backport some of these. There's a lot of cleanup to do. This branch has really diverged from master with the local stuff. Actually, what if I just disable the local stuff? How do I know it's maximally optimized? Well, one way to know is the GPU only has 10.4 teraflops. So if we could get 10.4 teraflops, there's no way to go faster. This is not using any local memory. Doing the globals every time. It's not bad. How does that compare to opencl? Wait, what? Okay, there's a fast one in opencl. And what's crazy about it is I didn't, it doesn't use any of the local stuff. Look at that one. 216.4. Oh, it's not consistently fast. Unless I got lucky or something. I don't really know how I got lucky, but I did. Little cheater. Oh, you know, we should also make the search go higher now that we can. You should all include 32. It's possible that it's higher. Let's put the locals back. For the fast one in CUDA, I had to do some crazy stuff. So who knows, maybe I'll have to end up doing similar stuff. .32 can be very slow. Thank you, Mtastic85. How many lines is tinygrad now? It should be 2,000, but it's probably a little bigger. It's bigger with all this crap. It's 2349. But a lot of this is just new crap that's going to be removed. Okay, the 32s there are terrible. Let's just leave that 32. Oh, thread group memory size exceeds the maximum allowed thread group memory size. That's interesting. Oh, yes, of course. Compiler encountered an internal error. Failed. Okay, well, the 3 issues don't work. Most of them anyway. Useless. .2 TFLOPS. Yeah, this is gotta be faster. I wonder what it's using. I wonder if there's some like hardware trick. All right, non-subscribers. Question time. And then we're done. So what did we do today? We implemented a metal backend for tinygrad, got it into master, and then showed that the metal backend was slightly faster than the opencl backend, where we also got speed ups by changing things to, never mind. We were just getting lucky and it's not actually any faster. But the metal backend is actually legitimately faster than the opencl backend for reasons that nobody really understands. But we will understand when we start decompiling these shaders. And that's probably where this is going to have to go. Probably what we have to do is we have to fix up that GPU sniffer thing and then decompile the metal performance shader. I mean, I assume it's compiled. It's in... We can also try to look. I've heard they're in LLVM bytecode if we want to look at them, and that's easy to decompile. So we can look at what the access patterns are in LLVM bytecode, see if there's any like inline assembly or anything. Yeah, we can see what their memory access patterns look like. That's probably the next step here. The next step is to look at the metal performance shader and say, hey, what are you doing? I'm gonna make macaroni and cheese and take a nap. Why does it say no module PyCuda? Because we're on a Mac. So Obstrite is not available. No module named PyCuda. If you're on an NVIDIA, it's available. It's interesting to think about how all these things run too. So they're like 32 wide SIMD machines. The Lion optimizer algorithm. Well, these, is this like an atom replacement? None of them are ever good. Are we getting more streams next week? I don't know, bro. Ask my agent who has my calendar. You can have an agent with a, I don't know, if I feel like it. Can't wait to test out metal. You're working on fixing examples MSGAN and it's taking 16 hours. Well, did you try kopt? Kopt is pretty good. Kopt should make it a lot faster. All right, Ethan 1G. I mean, somebody could make a peeing compilation video if it wasn't against the rules because it's copyrighted. They always claim, the new optimizers always claim they're better. I've noticed that the new optimizers never claim they're worse than Atom. It's kind of interesting. Yeah, that's a great theory, except for the fact that when I actually when I just go and run examples gem, oh, it's extra gem. It gives me more. Look at all those gigaflops, man. I pay $1,000 right now. Actually, if someone figures it out, I'll give you $1,000. If someone figures it out before I do and submits a pull request to this branch without like doing anything insane to get the full 8 teraflops, I'll give you $1,000. What's cheating? No. What do you mean? Like, if you like write like hand-hacked garbage, then if you write hand-hacked garbage, if you just have like a metal kernel that does it, I'll give you $100. No, if you use half precision, you get nothing. If you write a metal kernel on its own, I'll give you $100. If you integrate it nicely into tinygrad, and I guess $1,000 is for the upstream. Because $1,000 is for the upstream, $100 is just for blah. You gave me a metal kernel, and let's say $300 for some broken pull request. No, don't submit garbage. None of that's legally binding, by the way. But like, if you actually manage to figure it out, I'll be like, holy shit, nice job, and I'll give you somewhere between $100 and $1,000, depending on how tightly you integrate it into tinygrad. I did pay $50. I paid $50. I PayPal'd someone $50 for finding a bug in my max LLVM wasn't good enough. Can you get tinygrad merch? We'll give free merch to contributors. If you contribute to tinygrad, we'll like go back and we'll hook you guys up with some free merch. Once the Tiny Corp is making money. The metal backend was written in 20 minutes. Well, yeah, right? How long did it take PyTorch to write their metal backend? Yeah, tinygrad's pretty good like that. But I don't think the metal backend's going to be much faster than the opencl backend. I mean, like maybe slightly. What's the dot product of x and y? Determinant transpose in the metal standard library. Wait a second. SIMD group matrices. Oh. Never mind. Okay. All right. I'll make the reward real. I will make the prize actually real. It's $100 if you manage to give me a metal kernel that can achieve the full 8 teraflops of matmul on my 2048 by 2048 matrix. Okay, $100 for that. And actually, I just told you how to do it right there. It's literally just SIMD group multiply. Right. Yeah, that's so easy now. Just literally write that, $100. No, I'll PayPal you or something. SIMD group, look at this.
That's what it's doing. It's probably dead simple with that. Should we just write it? All right, come on, beat me to it. Beat me to it, $100. All right. Metal matmul.py. Let's go. Let's go. This is just gonna disappoint me. I'm gonna work hard on this and I'm gonna be disappointed. I can feel it already. I can feel it already. I can feel it already, boys. I can feel it already. I'm just gonna be disappointed. We don't need e.wait until completed. We have better ways of timing shit. Let's call it GPU something. Start. There we go. All right. Metal matmul. Let's go. SIMD group matmul. Doesn't even use local or anything. It's not reversing. I'm actually legitimately coding metal. Apple would be proud of me. Wait, uh-oh. No, this doesn't work. Oh. Elements per row. Matrix origin. Who wants to make $100? I don't want to do this. It might not even be fast. What if I do all this and it's not fast? Who wouldn't be using namespace metal? Oh, yo. Can we just read it? underscore underscore. Dude, they're just tensor cores. Monolithic metal.pcm? What's a PCM? CPCH? Data. Wow. Does someone want to make this work so I don't have to? Here's an example of how to use it. Good. Alright, well, let's just start with this. I hate their names. Probably wrong. Did you test it and benchmark it and shit? You want your $100, you gotta test it and benchmark it and shit. You can beat me right now and get $100. $1,000 I actually care about. $100, I'll give you $100. SIMD group store. Alright, let's just set n equals 8. I don't even know what I do for the SIMD group. I don't know how this works. I store it from all of them? b.copyin and p.random. Let's say nb equals np.random. God, I've heard this boilerplate so many times. No, who thinks it can multiply an 8x8 matrix? Tuple cannot be interpreted as an integer. Rand got an unexpected. You know what? I just have this written somewhere else, don't I? It's in kernel search.
Can someone fix my copy in too? No, I should start giving you money because then you'll be like, I want money. I'm not giving you money for that. You do that for the love of open source. Money is if you solve very hard problems. ACC. Very, very late, but if I found this. Oh no, this is that libpi metal bridge my ass. No match. Oh my god, it's C++. Oh, just backwards. That was easy. CL buffer has no object numpy yet because it's 2 CPU. Love of open source, you know. Ugh. All right, SIMD group load. SIMD group load. Why do you think I do it? You think I'm getting paid? Where's my money? The Tiny Corp loses money, guys. The Tiny Corp is the biggest money-losing enterprise since FTX and Theranos. Tiny Corp doesn't even get tiny money. I would settle for tiny money. We don't get shit. A.2CPU.reshape n by n. Comp equals nb times nc. And np is sort of all close. Yeah, of course it doesn't work. Hey, at least it looks like a matrix, right? That's pretty good. Wait, multiply, accumulate? Did I not do that? Did I just do that? It's not that either. Smurfd, thank you for gifting subs. I don't understand. Is this a matrix multiply or is this a... Okay. Let's set it to some matrices I can understand. Let's try np.i. Okay, well, it added them. Okay, that's not multiply or accumulate. Did I just put in the things wrong? All right, we need a SIMD group 0. We zero it out. Yeah, the problem is it's somehow storing something in there, and it should be 0. Where's metal SIMD group matrix? How do I zero it out? Oh, make filled SIMD group matrix. Oh, that's useful.
this in the docs? Okay, it's in the docs. Hang on. Creates a diagonal matrix with the given value. Make filled SIMD group matrix. Oh, do I not have to do 4? Oh, 8 by 8 is just a suggestion? Does that work? Of course not. Expected expression. How do we do that? Oh, maybe it's this. Work. Okay, that worked. Cool. Now let's see if that's actually multiplying or that's matrix multiplying. Those two are not the same. You'll notice that the NumPy one is significantly smaller than this one, which makes me think it might be matrix multiplying. Oh, sweet, they're equal. np.assert all close. What is that? Assert all close. Oh, np.testing. na-comp. Oh, that's fire, bro. All right. Never at the top, it just feels so unreachable. And this one we have to multiply by 189. Wait, that's a pathetic amount of gigaflops. Oh, it's just because flops. That's fine. Because flops is tiny. That's actually how many gigaflops we're getting, okay? So enjoy your 13 gigaflops. Okay. Now to just like scale it up. I don't want thread position grid. I want the other one. Thread position in thread group. No. No, I don't want any of this. There's another one that like works better. Is there another one of these? It's called like thread group position in grid. Thread group position in grid. There we go. Hold up, if I don't want to accumulate, that's a good question. The answer is you're forgetting about later. Later, you're going to want to accumulate, but right now you don't. Okay, so we're gonna have to go down like that. Who knows how to write a matrix multiplication? I don't. If I write this and it's not fast, it looks fast, right? Doesn't that function look fast? It's got 2 underscores in front of it. It looks fast, guys. It looks fast. And don't you think Apple would use this? Like, you know that's what Apple uses. Oh, imagine that rotation, yeah. Okay. So every matrix is just chomp, 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 chomp. All right. Oh. Okay. All right. SIMD group load. SIMD group matrix const thread group T. What? Undefined use of undeclared identifier. It's a little better, right? No, this one is just doing the same thing. All right, cool. See the ones? They're aligned. This better be fast. This better be fast. Okay. Matrix origin. Okay, we have, let's say, pos x equals gpg.x. Something like that. We'll fix it. Okay, and then this one, we have ulong2 matrix origin. Okay, ulong2 pos x comma k, ulong2 pos y comma k. And actually, these are both wrong. We have to multiply this by 8. Let's go. Okay, printf. Might just work. Did not just work. Okay, straight up zeros. There's definitely the right number being launched. Those two are being stored, just not that one. No, this should be times 8. No, that's not even right. That is probably right. Okay. All 16s. Let's try it with the eyes. That works. Let's see if we can multiply an arbitrary matrix. No. No, of course that doesn't work. Did I mix these up? Sometimes I mix these up. Wrong. Do I need to escape that stuff? Maybe. I don't know. I don't care. I don't need the printf. We're just going to randomly try things until it works. I think that's that, actually. Oh, no, all of them don't match. Do all of them not match now? All of them don't match there either. Okay, never mind. Let's multiply by I. That works. Does this one work? Weird. So I multiply things by I, it works. Just must mean I'm iterating over the things wrong. It must be those zeros. Let me think about it for a minute. Should be k times 8? No, I'm plus equalsing 8. Okay, let's try. It's interesting that that works. give this one try. I don't think it's that, but it might be. Interesting. Wait, no, it's just more wrong. Wait, though, okay, most of them match. No, none of them match. If I do that, 128 of them match. Let's try every combination. There's not that many. God. Wrong. You know, I hit a buzzer every time I do it wrong. Okay, like, it like almost works. Does it not work with I now? It would tell me it didn't work with I, but it did work with that. No, it does work with I. It's too hard to mess up I. It's annoying that I can't see. How do I make these ints? Great. I'm just kidding. Is that right? As okay, great. No, but see now, flip these. Cool. That still work? Great. Okay, stupid, but we just had to flip it. Here it is. Make it multiply real floats. All right, moment of truth. Let's make the matrix big. No. Let's ramp it up slowly. All right, we're getting 1 gigaflop. All right, let's try 32. Seems still the right answer. Come on, give me flops. Give me flops. Give me flops. A, the answer is wrong, and B, it's slow as fuck. How is the answer right for 32, but then wrong for big numbers? Oh no, it's actually right. Never mind, the answer's right. It's just slow. I did all that work, and it's just slow. You have to set the ATL high because like matrices are like big and shit. All right, put in lots of hard work
And we get 1.3 slow ass Cindy garbage. All right, but let's before we insult it too much, let's see if there's a way to make it faster. Or maybe this is just what Apple, maybe this is the appropriate speed Apple thinks you should have. Or maybe there's just faster algorithms if you don't M3. M3. Yeah, they want to sell me an M3. To be fair, this is not like a cache aware thing at all. In Google, I see 10 teraflops. Apple can probably sell me a subscription to go. I worked so hard on that. I think I need to block, otherwise I thrash the cache. I don't think it's that. It might be why this one's slow. Okay, should we work a little on figuring out why that didn't work? Why doesn't that work? No. Okay. Am I doing this because of? There's never a because of. .7 pathetic teraflops. You know what? I'm proposing a change. What's quad group functions? Oh. Okay, what if I just comment that out? Does that? It's fast because the loads don't actually do anything anymore. That gets me 7 teraflops. 7 gigaflops. The only thing I'm wondering is like, if there's like a way to make like a 4x4 grid of these and then do the loads. That's fast. If we don't do any loads. All right, guys, we're done. We're done. There should, I'm proposing they add a note to the, I'm proposing they add a note to the SIMD things and be like, you will waste an hour implementing anything using these things because they're slow as balls. My hand-coded kernel is over twice as fast, and it's still not as fast as the secret Apple kernel, which I don't know how it works. Yeah. No, the $100 is still on the table. If someone can figure out the trick to make this go at 8 teraflops, I'll give you $100. Should we up it? I mean, if it was just that easy, like if someone gave me this, it wouldn't have been worth $100. But like, it can ask 2 questions to Apple's team. $500. If someone mentions fucking Strassens, you know what? If you do it with Strassens, I'll give you $500. nice meta library. We do a really nice meta library. That was a pretty good use of today. See, like, imagine, I want you to imagine we were sitting there and we didn't even have a meta library and we were seeing the SIMD group things and we were like, oh, this has to be what makes it fast. Until we actually try to use it and it's pathetic and slow. I turned on subscribers so we don't have to hear the stupid conversation about whether the Unabomber could code. He's still alive, right? Write him a letter, ask him. You get 2 questions to the Unabomber with your subscription to the Freedom Club. No, he probably doesn't tolerate questions either, and I don't blame him. I mean, yeah, I'm memory bound, but like, it's really easy to saturate all the stuff if you don't use the memory. It's really easy to saturate all the... My micro benchmark does a fine job saturating everything in opencl if it doesn't use memory. I'm just sad. I just wish we got to 8 teraflops and then like I could end the stream in peace. But instead we wrote SIMD groups and they get 1.7 teraflops. Let this be a lesson to everybody who's like, I'm going to use SIMD groups. Don't. They're really slow. Right? And the truth is that lesson applies to nobody. No. I have verified the 8. The 8 is real. We're just going to have to figure out what kernel it's launching. Yeah, I wanted to see 8 teraflops too. No, I don't trust any of this optimization garbage. Like, as soon as I saw that it had C++ templates, we should have said no. I started calling that underlying metal thing. So I was like, okay, maybe it's not terrible and there's just a little bit of C++ on top of it. You think you can get gem at 8 teraflops if you block right. All right, let's see you do it. $100. The tinygrad doesn't have any money. I'm sorry about the $1,000. We don't have $1,000. But if someone gets 8 teraflops, I'll give you $100 before I do. And I will PayPal to you or Venmo it to you or send you Ethereum or whatever you'd like. All right, cool. Thank you for watching today's stream. I appreciate having you here. We are going. Look, the thing about me is like nothing. Every day it gets a little faster and a little bit better, right? And one of these days, if you want an autograph, you definitely can't solve this problem because only an idiot would want an autograph over $100. So yeah, that's the truth. Some days I wake up and I'm going to do something, and then I ask myself, would an idiot do that? And if the answer is yes, I don't do that thing. No raid today. I'm just today. Do we want a dejected audience who can't get 8 teraflops in their matrix multiply? No, they don't. So, bye everybody. Goodbye. I'm going to. All right. Hang on. Let me just pop the chat out. We got it. We got the flops, boys. We got the flops. You know, stuff's addictive, man. Alright, we'll wait for some people to show up in the chat. Yeah, but you can see we're getting 8.08 teraflops. And there might even be no reason it stops there. So, okay. I mean, we got the flops. Hang on, let me turn a light on. We got the flops. We got a Thai iced tea. We ordered food again. Oh, everything just happened. Everything happened. I would have streamed it all, but I can't listen to my hyper pop music when, you know, I hyper pop, bro. So yeah, I can't listen to music while I'm streaming. So no, that's just why we didn't stream all day. I think that's why I used to stream like 13 hours. It's not that I don't work 13 hours. I promise you I do. I haven't done anything. Like, it's not like I stopped working on this. You think I would have let it rest? You think I would have stopped until I got that fucking 8, boys? You think I would have stopped until I got that 8? No, we got that 8. Okay, so this is the solution. First off, I'm claiming my own $100 prize. So it is using the SIMD groups. There's a few very interesting things about this solution. First off, I put this random thread group barrier in here, just like for the lulz. And the random thread group barrier gets it from 6.6 up to the full 8. So, you know, there's that. Yeah. Why did that one only get me 7.5? We're back at 8. Phew. All right. I wrote I did so much. I had so many emotional ups and so many emotional downs in getting this kernel. So I found Apple's kernel. I'll show you Apple's kernel. No, it's not Apple's kernel. It's this. All right, so this is Apple's kernel. And so it turns out, first off, they're using SIMD group. So good to know Apple uses SIMD group. Okay, the way that I found it was in... Oh, also, I probably didn't have to... HAI, thank you for gifting subs. I probably didn't have to... I forgot what I was going to say. A lot of things I did today I didn't have to do. Oh, I probably didn't have to hack on the GPU thing. There actually is a new wrap in the mesa tree. So I should have looked in the mesa tree. That would have been nice. So I found this thing called Metal Library Archive. We'll give a shout out to UAO. And then I got Swift to build it. So you can type like Swift run. And it has a GUI. It has a GUI for no reason I understand. You can go in here and you can open the metal libs. I don't know why it has this GUI, but it also has this button and you can unpack them. So I just unpacked the thing and it's in this thing called NPS ND array. Oh, you guys missed LLVM. Oh, I used LLVM to find out which things it was actually loading. So these are all the kernels inside of the Pimpmaster Chef. Thank you for gifting subs. This stream, I'm only going to be on here for another 20 minutes. And then Alex is going to come home. We're going to watch some more Clarkson's Farm. But I just did want to tell you guys that we did finally get there. And it was SIMD group matrix. So, you know, all the hate on SIMD group matrix. Okay, I was reading this code. And you notice a few interesting things. First off, this. Little fucking cheaters. SIMD group async copy 2D. So, yeah, SIMD group... async copy to... Oh, and I had a whole thing where I updated brew and it broke my computer. Oh, you all missed so much. Wow, you missed so much. Wow, you know, you go away for a few hours and you just miss everything. But you know, I've been sitting right here. So this is LLVM IR. I used LLVM dis to get this. And you see that there's this thing called async copy 2D. Now, of course, this is a secret API, so you don't get to use async copy 2D. So I'm like, fuck, we're never going to be able to get it as fast as Apple because we don't have async copy 2D. Every time I should have killed it. I shouldn't have let it update. I let it update. My tmux is broke. It was bad. But I just needed to kill all tmux and that fixed that. And then I needed to manually symlink Python. Now I have Python in my path and I also have a newer Python. But okay. That's not the point. The point is async copy 2D. So I saw async copy 2D and I was devastated. But then I saw this line. And I'm like, wait, what is this? Why are the things 4x? And then I looked at it a bit more. And I saw all the 4x's. So yeah. Yeah, Alec 4x metal SIMD group matrix.
So I realized what it was doing was loading in multiple SIMD group matrices, and I don't know why I didn't think of this before. So I needed to make a grid of 4x4 of the 8x8s. And then you just load this one and you load this one, and then you go like, whoosh, right? Whoosh, you know what I mean? So that's doing the whoosh. Yeah, so then I just slowly crept up. If you're in the tinygrad Discord, you watched me do it. So I got 4.3, I beat it a tiny bit. Then I got 6.5. Then it turns out if I increase the local work group size, I could get it up to 6.7. And I thought that's where it was going to stop without having copy async. But then I stuck this thread group barrier in there, just random chance, and I got my 8 teraflops. So yeah. I mean, I don't really know what lessons there are to take away from this. We can try... You want to try like just manually unrolling some things and seeing if we get any, so like, should probably do some like Python templates here. But like kind of what can happen is these things don't have to finish before I go to those eyes. I don't know how much the GPU is already doing this. It might just be already doing it. That gives me the same. But, you think I want to jump an apple? I didn't turn it out. Wait, why? I just managed to tie their performance. Oh, wow, 8.1. That's the fastest I've seen it. Okay, cool. Manually unrolling the loop made it faster. Okay, that's great. Now, I don't know if, like, reordering these things is going to make it faster. Sometimes we get the fast one, and sometimes we get the slow one. Real brain spike. Well, you're the reason we're going to subscriber only chat. Yeah. Who knows why sticking the thread group barrier there does anything? By the way, this is the LLVM code that's being generated by this. Wait, how's that the LLVM code? Is it rolling it back into a loop? Where's my... There's only 4 calls there. It's somehow putting it like back into a loop or something. I don't even know. We should jump the shark, man. Unless that's failing. Oh, it's failing. Use of undeclared identifier mem flags. Okay, we should fix that. Because that's probably been in there a while failing. I wrote a little thing to dump the mem flags. I think I have to like include metal. We should also just fix the runtime.
someone wants to make that code good, I'd merge it. Okay, there's nothing called metal. What's it called? It's like metal standard lib or something. Include metal standard lib. Yeah, that's it. That can work. Okay. There we go. Look at those beautiful multiply accumulates. A little faster. But yeah, no, I mean, you guys really missed the stream today because I didn't stream it. But we read this, we dumped the Apple thing. We vaguely used it for inspiration, even though they have a secret async library that we can't use. And then we made it fast. There's ways to like interleave here. I still can't get over that thread group barrier and how it made it faster. How did I just get lucky and stick that in there and get my 8? In reality, it's probably doing the same thing as async copy. There's a chance it's even inserting async copies. I mean, that's the same 8, right? Like, I'm actually, I don't know why I really expect to be able to beat it. Where's M1 max benchmarks? See what happens if I make the matrix tinier. Wow, it gets way slower. If I make the matrix bigger, it's probably also going to get slower. Yep, way slower. Only matrix it works for, that one. But that's fine. Once you get one, it's easy to get the rest. Yeah, ritual is so good, right? Yeah, man. How does Say or Say Dream not have more more followers? Yeah. Max TFLOPS. Get about, it seems we can get about 8 teraflops pretty easily. And that's what I'm getting. So I don't know. I don't actually, I don't see a reason why it could be faster. Maybe it can't be. See, that makes it slower. You have to hit exactly this number, which, I mean, it is doing the matrix multiplication in a different way. Yeah, because it's worse. If anything other than 4 there is worse. I think it actually is somehow like batching these SIMD loads or something. Let me think of what's happening here. Yeah, I don't know. All I know is we did it. It's fast. And I can't actually think of a reason it would be faster. I mean, I guess
we can just try. Let's just try this. There's some chance it's a little faster. Slower. Ever slow, slightly slower. Okay, but now we can try the other optimizations I wanted to try. Like that can go there. Does that matter? Worse. That can go there. I think the GPU is probably smart enough to do this kind of stuff automatically. And like, we can unroll more with that same pattern. Let's just try 2 more. I don't think it's gonna matter, but I'm just like showing you like what's possible. Oops. These have to be 16. But yeah, this is a representative sample of what. Yeah, right. No, that song's unbelievable. It's like it just reminds me of, you know, being 19 and hacking. Okay. 9 gigaflops, but the wrong answer. Good deal or bad deal? I do not know. Not that good of a deal. Yeah, that's a good point. Oh, this one's wrong. Okay, those are plus 0. Those are plus 8. Those are plus 16. Those are plus 24. Oh, and then I still have to do one more round of, okay. I don't get out of doing the multiplies. Way worse. But yeah, I mean, I'm just saying, like, that's theoretically what the GPU can do. It's probably smart enough to do that. Like, it won't actually, the load won't actually block until something tries to access it. Let's just stick this one up here. Probably stupid. Slower. Way slower. How insane is it that that matters? .1 teraflops. Can we all just take a moment to appreciate how large a teraflop is? And then I think that's going to be my stream. Okay. So did it do this many operations? No. 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 It did this many operations, okay? If each operation was $1, we could pay off the national debt in 4 seconds. If each operation were each person could have 1,000 operations. Each person could have 1,000 of my GPU operations every second. Meaning my one GPU could give everybody more compute than like anybody had 50 years ago. Gotta go back a little more than 50 years. Can go back a little more than 50 years. Like, well, I mean, what were you really doing floats on? And by the way, these are float 32 operations on a relatively, we don't want to get into how many flops the brain has. It's very disappointing. It's something like this. Yeah. Brain is about that many flops. So that's the brain. And that's, whoops, don't include metal standard lib. And that is the, so let's see, we have, what's 20,000 divided by 8? What's 10,000 divided by 4? So if we have 2,500 M1s, wow, that's a lot of teraflops. Okay, I mean, there's probably no way to get it to go faster. Just kind of like by structure of the GPU. That would be my guess. I mean, matmul is usually something that they really optimize the shit out of. So now this is like the kind of thing that we can put into... we can put this into tinygrad if we want. .8192 should be the limit. Why do you think that? Why? What makes you think that, bro? Oh man, if you're allowed to have a slightly wrong answer, oh, it gets very fast. No, actually, that's not even faster, but I actually think that probably the best way to then improve this is to, it's interesting that just sticking a random thread group barrier in there makes it faster. And if you remove this, it really is a lot slower. I think there's also something called SIMD group barrier. Not fast. It has to be a thread group barrier. No, I promise you that's not. Can I do mem SIMD group? mem device. No, you have to put exactly thread grouping. And that gets you the 8. Probably has to do with some kind of coalescing thing. Yeah. All right, guys. You know, I don't like to end my streams as failures, so it just took a bit, but now the stream is a success, and we got our 8 teraflops. Thank you to everyone who watched today. Now we have a happy ending. And I can't play you Avril Lavigne's copyrighted song, Happy Ending, because it's copyrighted. Yo, you know how there's all those jokes about, never mind. You know what? We got the W today. We don't need to rip on Avril Lavigne. Or talk about, we could always talk about how beautiful Haley Williams is. Should have set the GPU to gaming mode. Yeah, so I think, I don't know. Tomorrow I'm probably gonna look into why. I bet there's a what these things are actually doing kind of thing. How different is this from what I was doing? Times 4 is 256. So each of those is only 256. The accumulator is massive, but shared across the it's interesting to think about what this function is doing and whether we can write it without using SIMD group primitives. I'm not sure the SIMD group primitives, well, no, they definitely do things because, I mean, this is just calling into this. This is like a library. I'd be very curious to disassemble this shader. Should we try to disassemble the shader? Get the mesa thing building. We kind of want to get this building. Mesa asahi. Yeah, see, look, they have this thing. For example, to trace an app. This library is only built if dtools asahi is passed. How do I build? Mason? Build Mesa. Building with Mason. The general approach is Mesa. Build dir. Problem encountered. Oh, I need the Mako module. Pip install Mako. Great. How similar? Everyone apparently copied CUDA. Dependency X fixes not found. What's X fixes? Oh, let's also pass in dtools. Can we pass that into Mason? Brew install xfixes? Lib xfixes. Let's try that. How many TFLOPS does it take? Well, so TFLOPS, you can ask more accurately how many TFLOP does it take? And that's a number you can figure out. Have you heard the unit petaflop days? What a funny unit. Kilowatt hours? Petaflop days. Okay. Let's try that. Ninja. Oh, look how fast Ninja is. That's so fast. I don't know what it's doing, but it's so fast. I love my M1, by the way. I have zero interest in Grayskull or TensorTorrent. Like, ship your shit, or nobody cares. Right? Like, if you're not going to ship it, if you want to, like... Okay, here's the thing. Once you ship it, everyone can see how good or bad it is. And you know, whenever a sales department has contact us pricing, it's not a good deal. Why did this fail? What is this? Lib. This isn't gonna work. It's not gonna fix it. I can tell already. But maybe it already built. I only need wrap.dylib. Yes, libwrap.dylib. Fire. That's a dylib? Alright, cool. That's all I needed. Dylib, insert libraries. libwrap.dylib. Abort trap 6. I hate abort trap 6. My least favorite abort trap. Probably no one updated it for Mac OS 13. Response probably fails here. Maybe one of these asserts is failing. I don't know what abort trap 6 is. Abort trap 6. How do I only build one target for Ninja? Okay, hang on. Target to query? Unknown target wrap. Alright. Mason.build lib asahi wrap. Unknown target, libasahi wrap. Oh, it's just called wrap? Why is that unknown target? Get bio kit, mason build. Did you know we were going to have to figure out how Ninja works tonight? Or we figure out where xutil is. Even worse. We have it. It's just homebrew include. Alright, how do I add a homebrew include? Mason add include folder. You're gonna help me with this? Extra depths. Include directories. A different problem. I just want to build wrap. Why can't I build wrap? Libasahi wrap. Okay, well, it did eventually build. I'll point out that there was another, I had another version of that file somewhere, if it mattered. Op x11 include. So maybe let's try that. Oh, notice how it automatically reconfigured. Oh, that was pretty nice. What? Now you're talking about taking Xanax? Bro, don't take Xanax. I don't know. I'm not a doctor. Do whatever your doctor says. George said, don't take Xanax. You know, I leave you guys alone for 1 minute and you're off talking about dumb shit. Okay. GLX commands. What even is all this? I've built parts of this before to get a compiler for
No. Okay, the abort trap must be somewhere else. LDB? Can I dilate insert libraries in LDB? Oh, you know what? Let's also not try debug equals 5. I don't know if I can dilate through that. Let's see if we can debug this. No. LDB dilate insert libraries. Abort with payload. Okay, it's like not passing things through correctly. Oh. So in other words, this wrap is worse than the other wrap. How complete is their shader decompiler anyway? Am I just going to be disappointed? Okay, I have an idea. This is the wrap that we were working with this morning, and this one doesn't crash. All right, there's my shader. Isn't it a beautiful shader? This is what the shader starts to look like. But does this have a disassembler? I dealt with exactly this before. Like you're just frustrated. Does this have a disassembler? Because there's like a half disassembler in here, except you can never get this thing to build. Also for the Qualcomm thing. Does this have a vertex.bin? This doesn't even have a vertex.bin. Biomap fields, dump mappings. Command stream. Where's my shader decompiler? Oh, this doesn't even have it. Yeah, this is removed. This, on the other hand, has a shader decompiler. So let's see if this one has a lot more opcodes in it. What? Well, it has to have a compiler, does it not? Compiler here. AGX opcodes. Even better, does it have a Python decompiler? Oh, that'd just be great. Oh no, it uses this. It uses. Oh, this is what it needs Mako for. It uses Mako to get this. I see. So all the opcodes are here. Are there more? Wait, this is just Python. I can like import this, right? Encoding 32 self.description. No, that's not what I want. I want a decompiler. Yeah, this is exactly what happened with the Qualcomm one. Let's see. Apple shader. No, they have to have one. Ooh. Of course. Our boy Dougall Johnson. Oh, this guy's the best, man. Oh, this is also the guy who did all the M1, all the So I'm sure he has a decompiler somewhere. No, this guy's such a boss. I'm pretty sure he also did the AMX stuff. I fucked that from Corsix, but yeah, he's emailed me once. Man, this is the real champion of M1 performance here. What? Oh, thanks, GitHub. GitHub's down. They don't want us to see. Disassembler. Oh, fire. Oh, you gotta love this guy. Oh, what a winner. Python 3, disassemble. Fun tinygrad vertex.bin. Yo, that's so fire. What a boss. Yeah. Okay. So like that's what it does. Oh, we have to figure out how to... Oh, that's so good. We have to figure out how to actually extract them from metal shaders. He probably has a way to do it. Emulator. Hardware tests. Wait, so how does this work? How does it actually run them? Dilate, insert libraries, replacer. Wow. So there's my random thread group barrier that I stuck in there. Device loads. I don't know why some of them are signed and some of them are unsigned. Did I mess up?
GitHub is genuinely down, I know. Wow. Wow, I wish I found this morning. Okay, either way, it's doing this. SIMD probably has good documentations for this. For each active thread, result. Now I wonder how the Apple one looks different. SIMD matrix fmad 32. Oh man, this guy's the king, yo. Metal archive extractor. What's arc? Objective-C arc. Shader. New library with data. Here, lib. Okay, how does he... Alright, he gets the metal function. Switches on the type. Oh, okay, here we go. MTL binary archive. Oh, this is great. Okay, great. Okay, we don't need to use the wrapper anymore. We should just be able to, let's just put it in my metal implementation here. Okay, hacks to get LVM. Put that under 6. Hacks to disassemble shader. All right. Device. New binary archive with descriptor. MTL binary archive descriptor. Okay. So we're just gonna do this, and then we'll have it dump shaders, and then we can like look at this shader, and we'll look at the shader from this morning that was getting me a pathetic speed, and now we have the new shader which gets a good speed, and we can look at the difference in the. Wow, how did I miss Dougall J? This guy's the best. What does he do? Yeah, his Rosetta 2 thing was great. Objective-C is the most fucked up language ever. Alright. What's a descriptor? intl binary archive descriptor. Okay, well, my device doesn't have that. New binary archive with descriptor. Supports binary archives. Oh, new binary archive with descriptor. Error. How's that different from that one? Use class methods. Oh, I've gotten this before. Okay, we got to use .alloc, .init. Okay, that's good. Now we have a binary archive with descriptor. Where were we stealing that from? Here. Okay. We have to arc.addCompute with descriptor underscore error underscore. Alloc init desk dot set compute function. What is CS? CS is fn, and fn is the libnew function with name. Okay. Work. Did I mean set compute function? In fact, I did. Okay, add compute pipeline functions with descriptor desk none. Works. Now we need arc dot. Let's just print dir arc. George, you should do this faster than an IPython thingy. Yeah, probably. Okay. URL. Are they kidding? Serialize to URL. Oh, just create a convenient NS URL. Oh, temp shader.bin. Is that a good URL? Probably be checking all those things for errors. Okay. Well, you need an NS URL. No, this is a joke. How do I make an NS URL? Oh, we need Coca. Can I just import Coca? Good, we got Coca. NS URL with string. Good thing we had Coca. XXD temp shader.bin. No. It's not that easy. This probably has an error. Error. Domain MTL binary archive, invalid URL. NS URL file. URL objects are the preferred way to deal with files. Oh, we just need file : // That's not surprising. Can we just type in a real URL and it'll upload it to the web? XXD temp shader.bin. Wow, wait, now? Python 3 disassemble temp shader.bin? No. Okay, because this is not just a shader, this is some file formats. It's a metalib executable. So we have to extract it. How do we do that? Oh, metalcompute. Oh, that was so long ago. This one. Okay. Metal compile tool. Compiler explorer. Files read shader archive. Archive extractor. Oh, this is the metal archive extractor, I see. There we go. Okay. Now let's just throw in os.system. Oh, that's terrible, George. Oh, you shouldn't do that. Oh, yeah, I know. George, but other people have other computers. They don't just you know, they don't just have your setup. Why would you do that? Well, I left them a comment and they can figure it out. You left you a comment, so you remember how to clone it later. Yes, you're exactly right. Boom. We dumped the shader, boys. Oh yeah, remember when we were happy with getting 4.2 teraflops? Well, let's see. Aha! Okay. So that's this one. This one does device. This just does device loads. And then SIMD matrix FMATs. This one does device loads, thread group stores, thread group barriers, thread group loads, a shit ton of FMADs, a few more thread group loads, and then way more FMADs. So this one gets you that, and this one gets you that. Why are some of them signed? It's just worrying. Who signed anything? That's not signed, that's not signed, that's not signed. Whatever. Interesting. So that's a single load. My pie passed, yeah, right?
But how cool is that we can just dump the shaders right here? Oh, that's so nice. Wait, dougall J is the king. All right. Is there any way we're going to be able to look at Apple shader? We could probably load it and compile it if we wanted to, but I have an idea it's very complicated. And actually, when I tried to get it with the wrapper before, it didn't dump it. For some reason, I don't really understand. Maybe because it's getting thrown off with this. We'll give this one try. You know when I say we'll give it one try, you know I end up just keep trying. It's not actually that many gigaflops. Don't get too excited. You see, it's not actually there. It's just that. Well, this is writing to vertex bin multiple times, but I have an idea it's not, because this is the same shader that's here. So this is doing something sneaky with the shaders. Whatever, do we really care? I mean, yes, we care. Because there's probably some secret load that it manages to do. Oh, I know it's doing a secret load. I know it's doing a secret async load. Let's read the docs and see if there's anything in there about secret async loads. Can't believe more people. Why is GitHub down? I can't believe more people watched this morning than watched it now when we actually made progress. Device load initiates a load from device memory, the result of which may be used after a wait. Oh, look at this. You see this? This is a wait. And then this is another wait, but that's that one and that's that. Wow, that's pretty good. So I think we're actually really getting all the benefits of, yeah, we're getting all the benefits of async, I think. And then that many of those. Okay, we may be able to get it to go faster, but we're not going to do it by hand. It's possible we can make it go faster. SIMD. Oh, this guy even writes nice Python code. Debug the signedness? No, that's not a real problem. I mean, you can look at my... I don't know why it says signed and not signed, but I don't really have control over that. Oh, I see what it's doing. So those two are actually there. And it does a wait.
jumps back here, does a bunch of adds, cache, discard, blah, blah, blah. I mean, it does know I can pre-compute all those, right? Why does it compute them every time? Why are these ints? Who let these be ints? Always use uint. It's still signed. I can't believe those were ints. I mean, I'm not getting duped into the shader twice, right? Just make sure I don't make the same mistake I made before. I don't like when it says numbers under 8. Okay. So I can do something like pos x 8, pos x plus 8, right? Does this actually change anything? I think that made it faster. Oh, let's just do it. Looks like the exact same code. In fact, it's so much the same code, I wonder if it's even doing anything. Yeah, because I got rid of the thread group barrier. Alright, what is all this stuff? Must be doing that all beforehand. Cindy matrix fmad 32. Okay, it clearly is unrolling that loop. I don't know why some of them are dot cache and some of them are dot discard. Oh, I guess if it's going to use the register again, it's dot cache. And if it's not going to use the register again, it's dot discard. I don't understand why there's so much up there. The loop should be tighter. What is this? What is this? Why is it doing this or? Oh, I guess that's computing the I guess that's computing the K. Oh, it uses that one a lot. See what the argument to device load is. Okay. Wow. It's a lot of stuff. It has to do a lot of math every time. I just don't like it. Look at all those instructions. Imagine it didn't have to do them. I don't think Godbolt's gonna work. Yeah, so that's great, but this is ARM code. This is Apple shader instructions. Like, you think that's a base thing? Oh, it must be loading into that. That's the address, and these are the offsets. Does that make sense? I should also be able to, hang on, where's that metal example? I should be able to mark these as const. Not sure it's gonna matter. No, same shader. What does that sign and unsign mean? I guess, okay, you want me to debug that? I heard someone wanted me to debug that. An unsigned or signed 32-bit register. Okay, well, interesting thing to note is probably what this stuff is doing is it's doing the math, which I don't really have to do because this is the same math every time. Yeah, I could just track that in registers and add them, which might make it faster. I'm like, what is this crap? Oh, that's okay. That's K. All that math could be removed if we were smart about it. And we'd be left just with the SIMD matrix and the device loads. And that's like an absolute minimum. Because each one of those, I think, is an fmad 32 across the SIMD matrix. Well, yeah, okay. So this is loading 2 registers. Okay, so that makes sense. And the SIMD is 32Y. So each one's loading 2. Yeah. Then each one's storing 2. Is there another way to express this? I mean, I should just be able to... No, I can't just move the pointer. Zeros all the accumulators. Oh, how nice is this? It's actually only zeros 2 local ones. Must be faster to load batch. We're getting thread position in grid, thread position in Cindy group. Well, this was stupid. It's honestly unclear if it would go faster. If I don't use them, that optimizes it to nothing. It doesn't keep the device loads, does it? No, it doesn't. I don't think there is an async. The async thing might just be totally fake. Let's see if there's any mention in here of async. No, just shouldn't replace her. Yeah, so if we go lower than the Cindy group somehow, and we figure out like what it's doing, there's probably no other way to access that function. Like, look at this terribleness. Oh, so many fmad 32s. Which makes me think that we could probably even get away with more. Like that 4x4 is not the max. But we will know that. We could probably do a little bit better too if we like divide it up, because like you'll see like it doesn't really need this one. This is not that smart, right? We could probably divide it up. Can't believe GitHub's still down. Yeah, it's Microsoft. What are you guys doing?
It's so nice too that these are the real shader instructions, because on NVIDIA you get PTX, and PTX are not the like real shader instructions. The real shader instructions are something called SAS. I mean, to be fair, I can get the SAS on NVIDIA too. But how cool. I don't know. Oh, I should add that back. That was bad to remove. Must be using my GPU for something. Great. Yeah, there's probably ways also to do this in a more cache-aware way. I didn't care at all about caches. And yeah, 70s. Guys, I promised you 8 teraflops. I delivered 8 teraflops. Don't ever forget that. When I say I'm gonna do something, I do it. Good night. Happy weekend. Enjoy Clarkson's farm. Let's see. Wait. Oh, you want rap? 33, it's my Jesus year. You can hear it here. Peel the orange, connect the dots. You feel the age, constrict your thoughts. Whoa. You think there's a difference between feeling the feelings and asking the machine to feel for you or draw for you? Say uno and draw for. Now it's Cinco de Mayo and you cry for nothing and know you can't fight the decline. You can't stop them scamming and lying. And no sick of damn it, I'm trying. God, I'm so over this place. I'm back in my home, in my place in its civilization, respite from a failed state, in a dark place, in a dark world. This year I just want to fuck famous girls. Yo, hit me up if you famous girl. We'll go to LA with this famous girls, get validation from famous girls.